Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody?
Well done! Well done!
River in his house. What's going on, Riv? Dun, 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 dun. All right. Today is, what day is it? Tuesday? I think it's Tuesday, yeah. Oh, it is Tuesday. Nice. Sick. Cool. I guess today was this National Dessert Day. I love desserts. Sexy Grandma. Wait, is this you, Grim? Why is your name not Sexy Grandma, dude? What?
Yellow.
Yo, what's up? What's up? Oh, wait, is this Omega Zeus? Is this Omega Zeus? Is that who it is? Wait, I recognize the name. I recognize the voice.
Yeah, that's me.
Yo, what's up, dude? Haven't seen you in a while. What's crack-a-lackin', man?
Yeah. And going to the second best school in Wisconsin. It's nothing.
Ooh,
nothing too crazy.
you're going to college?
No, not college. No, I'm not that old.
You said
Lakeview High School.
Oh, Lakeview High School.
Lakeview
Nice, dude.
Tech.
Congrats, dude.
It's pretty cool. I had to flex that real quick.
Yeah, no. Flex it, dude. Yeah. You should always...
I'm struggling
What's up? What are you struggling with?
real bad in geometry right now. We're on 3.10, right?
Okay. What are you doing in geometry?
But
What are you doing in geometry
right
that's
now,
struggle?
we're trying to figure out the distance between a point and a line, and I don't have the formula down.
Okay. Yeah. I mean, there's a way to memorize it, and then there's also kind of more of a vector way to think about it, but that way kind of sucks, honestly.
Yeah.
You want me to go over a question? Do you have one? Do you have a screenshot of one?
I don't have a
this works.
screenshot of it. If I could just hold on, wait, I could try to pull up a
Go find me
screenshot.
Go find me one. Go find me one. That's what I always say to the students. I say, you find me a screenshot, I'll help you do the question.
Do I post it in office hours or the chat here?
You can post in the chat here because you're already on. For everybody else that watches, we have like a new website that we use. You're lucky because you're here right as I'm streaming, so it's okay. But like during the stream, I get a pretty big line of people that ask questions, and so I have to use like a website for things. But you're here right now, so you can just post in the chat. I'll do it. And then I gotta figure out.
We gotta do 14 and 18 here.
Cool. Yeah.
Or on that.
Got it. Nice. Okay, I see it. 14 and 18.
So gotta find
the distance.
between
Find the
each
distance
pair.
between each pair of parallel lines with the given equation. Oh, I think this is actually not that bad, dog. Do you want to know how to do that? I think I think I know an intuitive. I don't think you need to memorize an equation for this. I mean, you could. And then what? 18.
I mean, it's not really that. It's more
I
so
see.
like
18.
the rest of it.
18 you need an
14
equation.
and 18, yeah.
Yeah, no, 14 you can do kind of like intuitively. I can show you, like, there's a fun way to do it. Basically what you do is you make one of the, since you know the two lines are parallel.
Mhm.
Why do you know the two lines are parallel, by the way?
Because isn't it like if you multiply them, they equal 1 or something like that?
So the key thing is to look at their slopes, okay? So what do you see?
Yeah, they're the same slope. They're the same slope. Yeah, I remember now.
Yeah, exactly. Yeah, if they have the same slope, then that means they're parallel. Okay, this is just a good thing to know from like algebra and stuff. Like, same slope means parallel, right? So if I have two lines, right? Well, we can actually draw these lines.
Yeah.
Let me just draw these lines real quick. It'll take like 2 seconds to do this. So this is a down slope, and one's all the way up at +5. So that means it's doing this. And then the other one's all the way down at like -5. So whatever, we could do something like this.
Yeah.
All right, cool. And I want to figure out the distance between these two lines, right?
Mm-hmm.
So one way to figure out the distance between the two lines would be to draw a line that is perpendicular to both of these lines. Okay. That's like there's not really memorizing an equation, but I think it's important to understand intuitively what's going on so that, that can help you out for later. So if I drew a perpendicular line from one line to the other line, do you know what the slope of that perpendicular line would be?
The slope is -2x, isn't it?
Close. So this one, right, is like -2x + 5, right?
Yeah.
This is y is equal to -2x - 5.
-2x -5, yeah.
Okay, but let's look at this one. So first of all, Hamega, what type of slope does this perpendicular line have? Is it a positive slope or a negative slope?
Negative slope.
Well, let's look. This thing is going up though, right?
Good job.
Yeah.
So it's going up.
Yeah.
So that means it has a positive slope. So I know it's got to be positive. The rule for figuring out the slope of a perpendicular line to a regular ass line is you take the slope of this thing, you make the reciprocal of it. The reciprocal is the same thing as like the flip of it. Okay.
Yeah. Wouldn't it be -1/2? Right.
Good. And then you multiply by -1. So this actually becomes positive 1/2x. Okay.
Mm-hmm.
Yeah. Do you see how that would be the slope of a perpendicular line? And then that perpendicular line can be like anywhere is what it can be, right? So one thing I could do here, right, is I could say, okay, well, let's think about the perpendicular line that just crosses through 0. Okay, like right here, yeah?
Mm-hmm.
Now, I know that this line must intersect these other two lines at 2 different points, right? So it's got to intersect this line here, right? Do you know how to figure out where two lines intersect? This is another good skill to know.
It's not a distance formula, no.
Not the distance formula. Okay, so this is the equation of the pink line, right? This is the equation of the blue line. And what the equations of lines do, Hamega, is if I plug in an x, it tells me what the y value is. Now, if two lines intersect somewhere, what can you say about their individual y points? If they're hitting each other,
they're a 90-degree angle.
it makes a 90-degree angle, but also the y points are the same, right? So, for instance, when this y point from this line equals this y point from this line, then they're hitting each other, yeah? So if I want to figure out where this is the long way to do it, then I'll show you the short way. But like I want you to conceptually see how this works. Because there's also a lot of really good like side skills here. These are like side quest things you really want to know in math. To find out where these intersect, I'm going to set this equal to this. So I'm going to say, okay, cool. 1/2 x. So
equals
good.
Y equals actually no -2x + 5.
Perfect. Okay. So now what we did is we just set these two equations equal to each other. Good. And this makes a new equation. And you can solve this, right? Watch. You can solve this for x, yeah? So I can be like, okay, cool. Let me just move 2x over. So if I move 2x over to the 1/2 x, what does that become?
plus 2x.
Yeah, we got to remember
It
fractions.
would become 5.
Close.
Yeah, 5 over 2x.
5 halves. Good. 5 halves x. Yeah,
5
perfect.
halves.
Nice. So you get 5 halves x is equal to 5, right?
Mhm.
So, wait, not, yeah, yes, 5 halves. Okay, cool. And then we solve for x here, right? By just multiplying both sides by 2. Because that gets rid of this. And then we divide by 5. So I'm going to end up getting x is equal to 2. Okay.
Wait, hold on.
All right, let me go a little slower. So we're good here, right?
Yeah.
If I add 2x to 1 half, I get 5 halves x. And then here I get, so this goes away, right? And then I'm just left with plus 5, right? Yeah. Okay. How do I strip that 5 halves x off of the x? You gotta strip it off. Strip the ball. Punch it out.
Yeah, multiply 2.
You can multiply by 2. You can also divide by, you could divide by 5 halves, which is the same thing as multiplying by the reciprocal. So I can multiply by 2 over 5. No, you're good. You're good, dude. Yeah. See, because this goes away. This is 1.
So, yeah.
So then you get x is equal to 5 times 2 over 5. That cancels. So you just get x equals equal to 2. Okay?
Yeah.
So, cool. So now I know x is equal to 2. So that's the x coordinate of this intersection, okay? Then
And you can just plug the x into the y.
You could plug it right in there. And so what do you get for the y coordinate?
So the y coordinate, you would get y equals -2 times 2 plus.
So you can do that, or Hamega, dude. You could. This one's even easier, bro. Right? Because we know the pink one and the blue one all hit each other at the same time, right?
Oh yeah, they're half of 2. So that would be y equals 1.
Bingo, dude. Nice, cool. See how that's 2, 1? Okay. Now let's do the same thing to figure out this point. Okay. We're gonna do the same thing. We're gonna set this equation 1 half x, but now we're gonna set it equal to this line, this bottom line. Okay. Because I want to figure out where this thing is. Yeah.
Equals -2x.
Good. Equals -2x minus. Yeah, Liam, I definitely do physics. Yeah, you're good. I do physics. What's up, Indians fan? Got people in the chat. Okay, good. So then let's solve that for x. Let's see what we get, right? You get the same 5 halves.
Plus 2. So 5.
Good.
X equals -5.
Good. And then solve for x, right? What do we get?
Divide 5.
2 over 5. Yeah.
2 over 5. How does it become 2 over 5 though?
Good. Okay, good. Okay, so here's what I want to do, right? I want to get rid of the 5. Anytime you want to get rid of something in front of a variable, you do the opposite thing. So I would be dividing by 5 halves, right, to get rid of this? Does that make sense?
Yeah.
Okay. So here, I'm technically dividing by 5 halves. This, like, scares a lot of students because dividing by fractions is fucking ugly, right? So another way to write this would be, I'm going to say this, like, divide by 5 halves. Yeah?
Okay.
And then do you remember the rule for, like, dividing by fractions? It's called, like, keep, change, flip. Have you heard that before?
You keep the one number.
Good. You keep this. You change this.
You multiply that to 2 over 5.
Good. Bingo, dude. Yeah. Do you see how I multiply both sides by 2/5? Multiplying by 2/5 would have killed this off too.
Yeah. So
yeah.
Okay. 10 over 5. Yeah.
Negative 10 over 5, which is equal to
-2.
Okay, cool. So now I got the y coordinate for this, the x coordinate for this one, right? That's equal to -2. Okay, and then how do I figure out what the y coordinate is?
You just plug in x
into this one. Good.
Yeah.
So you get -1, yeah?
Perfect. So yeah.
Perfect. Okay, so now here's a dope thing, dude. I have 2 points. Because the 2 points, the line that connects them is perpendicular, This is referred to as the shortest distance between the two lines. Notice how, right, if the lines weren't perpendicular, like let's say I measured between like here and here. You see how that would be a longer distance than this?
Mm-hmm.
Yeah, so by design, us creating this perpendicular line, that is the shortest distance between the two lines. And so now I have 2 points. All I need to do is just do the distance formula. Do you remember the distance formula?
Yeah.
For between 2 points? What's that?
Y2 minus y1 squared.
Good.
Plus x2 minus x1 squared.
Good. So this minus this squared, so 1 minus minus 1 squared plus
Or
this minus
1
this.
plus 1 squared.
Good. 1 plus plus. Good. And then so this becomes 2 plus plus. It's 2 minus minus 2 plus whatever.
Yeah. 2 plus 2 squared. So 1 times 2 that's squared 4 plus 16. Yeah, 20. And that
Good.
becomes
It becomes 17, I think, right?
4.
So, well, oh, you are right, dude. I fucked up. You did better than me, dude. Yeah. Sorry. Yeah, that's 4 plus 16 square root of 20. Excellent, dude. Right? Yeah, cool. Which is 2 square root of 5. Yeah.
Which is 5 square root of 4, yeah. Oh, no.
No, 2.
Yeah, no.
Then pull it out, right?
2,
10,
2,
2, 5.
Yeah,
What's up,
2,
Chris?
4.
Christine, there is a Discord. If you go to that website down there, Christine, there's a Discord. If you want to hop in the VC and talk with us, that's totally cool. Yeah. It's just a lot of people are scared to talk. Hamega's a homie. Hamega, you've been in our server for what, like 2-3 years at this point, yeah?
Yeah.
Yeah.
Been here since like 7th grade, I think.
7th grade. And what grade are you in now?
9th.
Look at that. 2 years. Okay, sweet. Okay, so there you go. You got the distance. Okay. I don't think this is the way your teacher wanted you to do it, but I wanted to show you this because there's a lot of really cool math things you need to know in math to be able to do this, and I wanted to make sure you knew it. And also so that you kind of get more of an intuitive viewpoint for like what the fuck the distance is between two lines. Otherwise, just memorizing formulas doesn't really it doesn't stick, dude. You're just like, wait, what the hell is this? But now, okay, so let me show you what the equation, because this works when you have the equation of two lines. This kind of sucks because, well, actually, this isn't bad because, well, they
kind of have it.
Oh, this is easy mode
No,
here,
I
bro.
don't
What?
think
This
so.
one's super easy mode.
So
This one is harder
Don't
for
you-
sure.
we got it. Yeah, we got it. All you have to do is 18.
Okay, then let me just show you 18. 18 is easy mode, dude. Watch this. Watch this. Okay. So it says from the line to the given point. So y is equal to -3, right? What does y equals -3 look like?
Yeah.
What does it look like? Is it what type of line is that?
It's down. It's just
It it's not down. I mean, it is down, but it's horizontal.
negative. Okay, yeah.
Okay.
Yeah, it's
And then
horizontal. I just
No, you're good. You're good. And then the point is 5, 2. So that's 1, 2, 3, 4, 5, and then 1, 2 up. So then that's here, yeah? If I want to figure out the distance from this point to this line, again, you just want to draw perpendicular stuff. Perpendicular stuff is how you really figure it out. This is what it is, right? And so cool. This point right here is what is this? This is 5, 2. If I go straight down, that's gonna be 5, -3. What's the distance between these 2 points? You don't even need to do the distance formula at this point. You should be able to just see it.
Yes, -5.
-5, nice. Peak content, thanks Usari. Appreciate it. Yeah, Discord down there. There's a link. TikTok will not let me post links in my chats, so you have to go type that in. Or you can go to my profile and the link in the bio has it, guys. You can go to that. Yeah, that has it as well. Go check it out. Okay, cool. Does that make sense, Omega? Yeah. There is like a fucking ugly equation, I remember. Yeah, this is it, dude. Fuck this, dude. Damn, this thing sucks. What's up, Jaden? Here, let me pull it up. Oh, River wants to come up. Sorry, my bad. Okay. I recommended you. Wait, sorry. Let me get through the chat. Sorry, I haven't even gotten to the chat yet. I recommended you to my TA yesterday, and he actually wrote your info down. Oh, sick. Yeah, tell him to reach out. I'm always happy to talk to other educators and stuff. But nice, cool. Glad we helped out Hamega there. That was kind of fun. I'm gonna post this for what was it? What was his name? Something Sexy Grandma. Was that his name? Sexy Grandma. Yeah. There's the other equation you could use. I never understood what a determinant is for a 2x2. What does it tell us? It kind of tells us the magnitude. Determinant is kind of like, yeah, I think it's kind of like the magnitude of a matrix. Maybe? Here, let me get, I think River wanted to come up and say something. There you go. Yeah, Sexy Grandma. I just, here's the, I'm trying to like post the image. Why is it not posting the image, dude? What the hell? One sec. There we go. I don't know why. What's up with Discord? Never mind. Anyways, this is the other equation that you can use in order to figure out the distance of a point from a line. You have to put the line. Oh, you can't hear me in Discord? Oh, that's weird. Yeah, one sec. I need to restart. I need to restart the Discord channel. One sec. I don't know why it's doing that. Discord, bro, giving me issues today. Okay. All right. There we go. That's working, yeah? Oh my god, yeah. What was going on with Discord? Discord, you silly bitch. Okay, there we go. What is this? So this is the equation for figuring out the distance of a point to a line. And I was showing how this can be done if you have the equation of two lines. There we go, River. Now you can come say hi. Sorry. If you have the equation of two lines, you can figure out what the equation of the perpendicular line is. And then from that, you can find the intersection of like 2 points, and then you can find the distance between the 2 points. And that's one way to do it. There's this thing they make students memorize, which I think the basis of this thing is something to do with linear algebra. It definitely has to do with like vectors and dot products, but they just haven't memorized it and like whatever. You couldn't see the screens either. Okay, well, luckily I stream on Discord. I stream on Twitch and TikTok and YouTube, so I hope you can see on one of those. But thank you for telling me. Yeah, it was working fine a second ago, and then I guess Discord just shat the bed. Okay, cool. Good question. We'll give a point to Sexy Grandma. Add amount 1, Sexy Grandma. Good. The Batman question we did was on the unit test. Oh, wow. So wait, did you know how to do it then, Omar? Dude, that question kind of sucked. Right? It was like Batman accelerated, and then he stopped accelerating, and then you had to figure out the distance between Batman and the other guy. Yeah, that was, oh, it was bonus. Oh, okay, cool. Yeah, that one was kind of ass, honestly.
Wait, is this the line of equation?
Yeah, this is the equation of a line, figuring out the distance between them. Okay, I have a ton of questions coming in. Nicola got one too. Thank you. Nicola, I got your email as well. I'll talk to you about it. Where did you send your question, Jaden, before I start going through all the ones in the queue? Jaden?
Office hour.
Oh, you sent it office hours. Okay, which one do you want me to do?
Yes. Wait.
I see a very big IGSC.
My math got 31. The vector problem come out, and then I skip.
Okay. So which one you want? Which one you want me to help you on?
Go up.
Okay.
This one. This one I don't understand.
The C?
Yes.
Okay, let's do it. Omar says, dude, oh yeah, and the 60-second head start, dude. Yeah, dude, that question's whack. It's just intentionally tricky. I don't know. Physics is supposed to be rigorous. No. Stop. Okay, here we go. Jaden, let's do it. The diagram shows a solid sphere with a radius of 6 centimeters inside a cube with a side length of 20. The cube contains water to a depth of 15. The sphere is removed. Calculate the new depth of the water in the cube. Oh, this is a very cool question. Yeah, okay. So, here's the key concept here, Jaden. The sphere is taking up volume, right?
Yeah.
So, like, the sphere... So, what we can say is that the volume of the sphere plus the volume of the water equals, like... And it's not... It's like the volume of the cube that's filled. The volume of the filled cube. But the cube isn't fully filled, right? So... It's really a rectangular prism.
What do you mean not fully filled?
We know it's not fully filled, Jaden, because look, the water line only goes up to here. Like there's air. There's air in the cube, yeah?
So okay.
Because see, they say the side length of the cube is 20, right? So they say this length right here, Jaden. This is 20 centimeters. This is 20 centimeters, okay? If the cube was filled, the water line, Jaden, should go all the way up to 20 as well, right? That would be a filled cube. Cubes have all the sides are the same size. All the sides are the same size. Yeah. Okay. So here's the key thing. All right. So when the sphere is in there, right? It's the amount of like filled volume, which includes the sphere and the water, is going to be a certain amount. And we can figure out what that is, okay? That's going to be length times width times height, right?
Yeah.
Okay, so that's equal to 20 times 20. I'm going to do everything in centimeters for now, because all the units will cancel eventually. So that's 20 times 20 times 15, right?
But why do we need to calculate the cuboid?
Calculate what, sorry?
Why do we need to calculate the volume of the cuboid?
Good, because eventually I need to calculate the new depth of the water in the cube. So what's going to happen, Jaden, is I'm going to remove the sphere. And when I remove the sphere, this is going to go down, right? And that means the height is going to have to go down. The height of the water is going to have to go down.
So I take out the sphere and then...
Yes, but first we need to know how much water is there. We don't know how much water is in there, right? So I'm going to show you how we figure that out. What do we know the volume of the sphere is?
4/3 pi r cubed.
Good, so that's 4/3 pi, and then they said the radius was 6, right? So 4/3 pi 6 cubed, okay? Plus V water, all right? Do you see how this is going to help us a little bit? Because now I can solve for how much water. I can solve for the volume of the water, right?
Yeah.
Yes.
Yeah.
The reason why I need the volume of the water, Jaden, is that eventually when the sphere is gone, only the water is going to provide height in the cube. Okay? It's going to provide volume that provides height.
What is cylinder?
Sorry, what?
What if it's cylinder?
What if it's a cylinder? Oh, that's fine. I mean, what if what's a cylinder? Like, the cube is a cylinder or the sphere is a cylinder?
Sphere.
Oh, if the sphere is a cylinder, that would be V is equal to pi r squared h. Or really pi r squared L. It's like the length of the cylinder is what we'd say.
So what's the difference between 4/3 pi r cubed and 4 pi r squared h?
Oh, it's not 4 pi r squared h. It's pi r squared times L. It's just two different things. I mean, a sphere is a ball. A cylinder is like a can.
But why is 4/3 pi r cubed though?
It's just what it is. I mean, I could go into the calculus of how you derive it, but just memorize it for now. I mean, it's given to you. They give it to you. This is also something you need to know. Like, as a middle school, high school student, you have to know what the volume of a cube is. Sorry, of a sphere. You should know what a cube is as well, but, you know. There's a way to derive this, but it would require me teaching you calculus right now. And That's, you know, no spoiler alerts.
Okay, so
Okay.
I'm not taking calculus. I'm not.
You're not taking calculus yet. Yeah, so just know that that's what it is. Okay, so let's get some numbers together, right?
Yeah.
So let's do 4 divided by 3 times pi times 6 to the third, yeah? So that's 904.78. Thuma says, can I explain Rolle's theorem and the mean value theorem? I can. The best way for me to help you, though, is to give me a practice question on it. My big philosophy in life is that you learn by doing. If I just, like, explain something to you and you just see it, you're like, all right, that's cool. But unless you actually do something with it, it's not really going to, like, stick. What's up, Becky? Okay. So this right here is, I believe, 6,000. I can definitely help with trig, yeah. Yes, I can help with trig. Okay. So, perfect. There you go. That's exactly what you should do, Thuma. Yeah. Now, Thuma, can you put that, sorry, can you put that on, can you put that here? Can you put it in the website for the queue? That's where I'm pulling questions from. Otherwise, it gets impossible for me to keep track of, like, who's asking questions on like, whatever chat thing. Okay, so now I can solve for V of the water, right, Jaden?
You minus. It's like
You minus. Good. Yeah, so this is equal to 6,000 minus 90. Let's just say 905. I'm just gonna round things for now. Okay. So that equals 5,095. Yeah. Cool. All right, that's velocity.
Cool.
That's the volume of the water. Okay. Now what happens is the sphere is removed. Okay. So when we're now looking at the filled volume of the cube, the sphere goes away. This is gone. Okay. And I'm just left with V of the water, which is now 5095. Okay. And this will equal to the volume of the cube, which is filled. And that's 20 divided by the base. Yeah, exactly. 20 times 20 times its new height. This is like the new height of the water, right? Does that make sense, Jaden?
I'm still confused.
You're still confused. It's okay. All right. So, when the cube is filled, right, up to a certain height, right? That could be seen as like another rectangular prism, whatever device shape that has a length and a width and a height. And this is like the height of the water, okay?
Yeah.
So that's 20 times 20, because that's the base, right? Times the height, which is 15, yeah? Okay. And
So I need to find the volume of the water then.
good. So now so that at the beginning included the volume of the sphere and it included the volume of the water. We used these numbers to figure out the volume of the water that's there.
So I need to figure out the volume of water then.
Of just the water. Because now, when you remove the sphere, okay, this goes away. Like, I'm pulling the sphere out, right?
Yeah.
Now, just the water is creating, like, the filled cube, right? At the beginning, the filled cube is due to having volume from your sphere and having volume from the water around. Eventually, you pull this cube out. And so if you pull the cube out, the water line is going to go down because there's less volume in it.
So I pour the water out.
You're not pulling the water out. You're pulling the sphere out.
Oh.
Yeah. If you pull the
But
water out, then there's no water line anymore.
Why do we need to take out the sphere?
Because that's what the question says.
Oh.
It says the sphere
so
is the sphere is removed.
Oh.
Okay. What's up, Liashi?
So I need to minus that.
Yes. Well, you can minus it by just like getting rid of it, right?
So find the new height of the water? That's the question said.
Yes, so that's this. Yeah, Newman says it's like putting a rock in a cup. The water rises and then you take the rock out and the water goes down. Correct. This is IGCSE, I think. Is this O levels? Are these O levels, Jaden, or what?
I don't yeah. I think I'm taking basic
Here,
level.
whatever this is, Mark. Cambridge IGCSE. It's international education, so I'm not sure exactly what it is.
It's my school.
It's his school. It's his school.
My school is in
Were you in Malaysia, right? Are you Malaysia? Or I think so, right?
Malaysia.
Yeah, isn't that cool? Yeah, look at this. We're helping students all the way from Malaysia, dude. I live in Los Angeles right now. Isn't the internet beautiful? I think it's cool. Okay. So, now all I do is I just divide both sides by 400, yeah?
Yeah.
So, this is the volume of the water. This is, like, the volume of the filled cube, which no longer includes the volume of the sphere. And that's still the base, which is 20 times 20, length times width, times the height. 20 times 20 is 400. Divide both sides by... But what?
But where is the H come from?
Where's the H come from?
In the diagram.
So that's from the volume of a cube. The volume of a cube is equal to length times width times height.
Yeah, I know, but where does the H come from? The height of the water?
Yes, it's the height of the water. So right now, the height of the water was equal to 15. But when I pull the sphere out, when I pull this thing out, the height of the water is going to go down.
Oh.
Yeah? So that's why we're figuring out the new height with just the water. It doesn't have the sphere in it anymore.
Okay.
Yeah? Starting to click? Am I a good boy? Haravel. Oh, man. Isn't that a new joke where everyone, like, goes up to the cops and says, like, give me your badge number and then says, good boy? Don't do that. Please. All right. So 5095 divided by 400. So you get a new height here, Jaden, of 12.74 centimeters. Okay. Yeah, here's the Q there. The Q's actually... I need to clear a little bit the Q from yesterday. My 9 looks like a 4, does it? No, but my 4s have lines through them. The same thing that my 2s are not the same as my Z's. My Z's have lines through them. Anyways, yeah, okay. Cool. Does that make sense, Jaden? Yeah?
But okay, so the whole volume is like, I need to make the water go down by removing the sphere.
Good. Yes.
And
So
if I
the whole
remove
volume
sphere, then
is equal to the sphere plus the water. We use the initial condition, so the first situation where the sphere and the water are in there together, and we know what the height is to figure out the volume of the water, so that when we do this, now we can just plug in the volume of the water.
But why do we need to calculate the volume of the sphere before getting...
Good, because I need to get the volume of the water, because I have no clue what the volume of the water is. They don't tell us anywhere what it is.
So I need to calculate the volume of the sphere before I can get the volume of water.
Yes, you do, for sure. Here, I'll save this for you. I'll save the solution. Because then, yeah, my queue is already 11 questions deep. I gotta move on questions.
Okay.
Is this cool though? Does it make sense? Yeah?
Yes.
Nice. Okay, great. There you go, Jaden. I put it in the stage chat for you. All right. Locked in. I do engineering. Yeah, as long as it's not super fancy engineering. Like when they start using dumb jargon and stuff, I don't really want to do that stuff. Like, I don't know. Like heat of steam fusion. Like, I don't fucking care about that one. But if it's like basic thermo engineering, then yeah, I could do that too. I can do statics. All right, let me get rid of some of the questions that were already done here. So, yeah. Nikola, you are next up. And then, so here, if anyone ever wants to see what the queue is at, that's the queue right there. So Nikola, I'm going to do one of yours if you're here. I think you are. Diffie Q and statics. Yeah, I could probably do that a little bit. Yeah, might be a little tricky. And then HH, and then Thuma, and then River. That's what the queue's at so far. If you want to add your name into the hat, please do. There's a website. Nikola says, yeah, I'm still here. I'm still here. Let's do it. Yeah, I appreciate your email, Nikola. Just like, I'll respond to it formally, but like, my quick opinion is, don't worry, this happens all the time. Well, I mean, which is kind of concerning. But professors do fuck up with calibrating what they think the class can do and what the class actually can do. So when he gives this test out, if everybody fucking bombs it, because again, he's expecting way too much out of a 5 series, he's gonna have to curve it. So I would say take the first test and then see what happens. I agree he's already not being professional by not giving you guys an equation sheet. He's not giving solutions for the midterm. Like, he's being a cock, like, in general. But get through the first test. And then if that looks devastating and enough kids start rioting and revolting, I can point you to the correct channels to, like, get that fixed. My guess of what's going to happen is that he's clueless about what level he should be teaching at, that he's going to get the message when he gets the tests back. Because if everybody in the class bombs the test, he's going to realize he fucked up. And that's when he's going to have to readjust how he teaches. Or he's going to have to massively curve, which I don't agree with. I hate curves. I think curves is a lazy... I'm going to write a big LinkedIn rant about this, but curving on tests is lazy teaching. It's professors and teachers who don't understand the difference of what the class knows and what the professor thinks they know. If you're in tune with your class and you understand what their capabilities are, you don't need to curve. And also, if students are bombing your test, it's a reflection on yourself, not really as much on the students, you know. Students try their best. I don't think everyone's intentionally, you know, not putting in the work. But if everyone starts bombing the test, it's because the teacher didn't write a good test. Or they didn't teach the things that were supposed to be on the test. So they screwed up twice. Yeah. Curving is where, like, everyone just gets bonus points. Or, like, for instance, instead of an A being a 90, an A becomes like a 65 or something. Like, they set the levels differently. Nicholas says, he sent out an equation sheet recently, but it looks like stuff we haven't really learned. But thank you for the response. I'll get back to you. Yeah, let me know how the test goes. And then, yeah, if he's not curving and if there's a lot of bad things going on, I'll talk to my people at UCLA and see, like, what the appropriate response is. Usually sending enough emails to the not the dean, enough emails to the department chair, because he's the one in charge of hiring the professors. Enough emails to the department chair from enough of you guys in the class. Eventually, he has to notice and he has to do something about it. Otherwise, I mean, it's his ass on the line too. What's up, Jake? How do you redistribute the class if the average was bad? So what I do as a professor is I throw out questions. So if, for instance, on a test, like 20% of the class gets like question number 8 right, I'll just throw the question out. Because that indicates to me that A, like, I wrote a shitty question, or B, I didn't teach well enough for students to answer that question. So I'll just throw it out. Like, I mean, it's a bad question. Yeah. Need more people to see this? Cool. Well, boost us to the algorithm. Hit like, hit subscribe, hit follow, hit share, do all that stuff, and eventually my voice will be heard loud enough. Okay, but let me help out Nikola. This is good. Insulating solid. Ooh, this is fun. Rational function in my TikTok is popping off. Yeah, we got a couple people on TikTok. Yeah, a lot of chatters today. That's great, guys. Yo, Unc, you saved me. Fuck yeah, dude.
Good job.
I'm glad I did. You saved yourself, but I just helped. Yeah, that's okay. I teach physics. I teach physics at UCLA. But this stream I teach anything math or science, middle school through college. So okay, all right. An insulating solid sphere of radius r has non-uniform. Dude, bro. Dude, what is this dude doing, man? What non-uniform charge densities for a pre-med physics class? No. Engineering physics, yes. Pre-med physics, no. This is so wrong. Okay, find the electric field as a function of r for r is less than r. Find E of r for r greater than r. Assume spherical symmetry. Okay, so part B is the easier one. Well, actually, it's not. Sorry, because we still got to integrate. Fuck. Oh, this sucks. All right, whatever. Okay. So, Gauss's law. Yeah, it's not. Yeah, Femvox says non-uniform density. Nice.
Nice.
Yeah, but not nice if you're a pre-med. Because, yeah, I don't know. It's not hard calculus, but to me, it's asking a lot. Okay. So, E dot dA is equal to Q enclosed over epsilon naught. Let's draw our sphere of some charge. So, we got this. And then this is radius r. Okay, so this is radius r. So what I'm going to, since I know this is a sphere, that means it's spherically symmetric. And spherically symmetric means I also want my Gaussian surface to be a sphere. So what essentially I'm doing here, Nicola, is I'm going to start creating these like inside spheres that are going to have some radius little r. And we're going to look at the amount of charge they enclose. And we're going to look at what the electric field dotted with the surface area would be. Okay? So, E dot dA for something that's spherical. So, it's like, so for spheres, this is just going to equal to E times 4 pi r squared. Okay? So, important. This is technically E of r times 4 pi r squared. So it's saying the electric field at r times 4 pi times r squared, because this is the surface area of this imaginary surface, of this imaginary shape I'm making inside the big solid sphere. Now, to figure out Q enclosed, this is a little trickier. So Q enclosed. Oh man, oh this does suck. Because it's non-uniform. Okay, so if the density was uniform, non-uniform means the density is changing. So in this case, the amount of charge is a lot at the center, and it's like less as you go further out. This is a pain, because usually to figure out charge enclosed, you would just do charge density, sigma, or I guess, sorry, you would do rho. So this is charge density. And then you would multiply it by the volume. Okay? This is usually how you would do it. Yeah, not sigma, rho, sorry. Sigma is surface charge density. The issue is this assumes that the density of the charge, so the distribution of the charge, is uniform, which means it's the same. Which means at the center, I have the same amount of like charge per unit volume versus out at the edge. You can think about this as like something that has non-uniform density would be like a peach, right? So a peach has like a pit, right, at the center, and then as you go further out, I don't know, maybe it's less dense than the pit. That's something with non-uniform density. Uniform density would be, for instance, like a bowling ball. A bowling ball has the same amount of weight per unit volume anywhere throughout the bowling ball. So, this assumes uniform P, uniform rho, which we don't have. So, for non-uniform rho, it is an integral. Exactly, Jake. And this is why this is kind of a pain, because it requires a little bit more calculus than I think a pre-med is used to using. So for non-uniform rho, Q enclosed is going to be equal to the integral of rho dV. Yeah, exactly. Your electrical engineering course. Exactly. Yeah, I believe it, dude. So this is rho dV. So it's the charge density, which is technically a function of R. This thing changes, integrated over all the volume that you go, okay? If your charge density is a function of radius, this is college physics. The best way to figure out this dV is to do what's called the method of shells. So what you're going to do is you're going to take the surface area of like a small shell. So like, I don't know, like this. And you're going to get that surface area. And then you're going to multiply that by like dr. And that equals like the volume of like, I'm trying to think, like the skin. But then the skin just keeps getting bigger and bigger. Does that make sense? Yeah, I'm not doing r squared sine theta dr d theta d phi. No, fembox. No. We're making this easier. Okay. dV in this case for spheres with densities that are a function of r, this is going to be equal to 4 pi r squared dr. Okay? Because this is the surface area of a sphere. And then this is like the thickness of that sphere. Like a jawbreaker. Yeah, it really is. Okay, maybe I can like let me see if I can get an image for this. Spherical shells integration. I want something that looks nice. No, but not. Does no one do this? No one do a nice little picture of this? Someone really should. Oh, concentric spheres. Yeah, okay, wait. Wait, did I say spherical shells? Yeah, sorry. Concentric. Concentric. It's like an onion. It has layers, yeah. Here's integral. Thanks, man. I appreciate it. Yeah.
Good job.
Bless you. Bless you too. Okay. I want a picture. This kind of shows us. Like a jawbreaker, yeah. This isn't vector. So what we're doing right now, this is a college physics class. Is what this is. Like the planet, yeah. And also like blowing up like a balloon, yeah, exactly. So here's what's happening here. When we're doing this integral of the density with the volume, this volume is so 4 pi r squared. That's the surface area, right, of this sphere. And then we're multiplying that surface area by like some thickness dr. And that gets us a volume, right? Remember that volumes are usually equal to like the surface area times like the height. So for instance, if I was doing like yes, Jake. Yeah. So if I was doing, for instance, like the surface area of a cylinder, if the volume of a cylinder, right? You take the surface area, which is like this, and then you multiply it by like how high it is. And that's like the height. In this case, the height of these onion shells, jawbreaker shells, whatever you want to call it, that height is dr. So, yeah, if this is like r, this is like dr. And then that gets you a volume. Yeah. So, does that make sense, Nicola, so far? I don't know, Fem. There's different latencies on different things. Okay, great. Okay, so this is going to be equal to rho r, and we're going to integral from 0 to r, because the charge enclosed is integrating all the onion slices from the origin to like where I am measuring the electric field. And then dV is going to be 4 pi r squared dr. And then the cool thing here is that rho r is actually equal to rho over r squared. Thanks, Sharon. I love the roses. I don't know what I do with them. Y'all need to what do I do with these TikTok rose things? Do you guys know TikTok? Can you tell me what I'm supposed to do with those things? Do I go like yummy, yummy ice cream, and like someone buys me a Porsche? It is like an infinite Russian doll. Yes. I love all the... Okay. So this is rho over r squared. So now my integral becomes 0 to r rho over r squared 4 pi r squared dr. R squared's going to cancel. These are constants. So then I just have 4 pi rho integral of dr from 0 to r. The integral of dr is just r. And then that's evaluated from 0 to r. So it just becomes 4 pi rho r minus 0. And so it's just 4 pi r. Okay. The rose means I get to stay on the island. Aw. Love that. We got some Bachelor vibes going on. Okay. 4 pi r. So, okay, cool. So the charge enclosed is actually linear with r. That's kind of fun now. And don't forget the rho. Yes. Almost forgot the rho. Sorry. There's also a rho here. Yeah. So then this comes up here. And so you have 4 pi rho r over epsilon naught. Okay. And now I can solve for E. And so I'm going to get that E of R is equal to 4 pi's will cancel. One of the R's cancels. And so I just get rho over epsilon naught R. I think, right? I think that's it. Yeah. Okay. So there you go, Nicola. This is the electric field for R is less than big R, okay? Now, the second part, they said find the electric field for when R is greater than big R. So that's asking me, what is the electric field when we are outside, okay? Well, outside is actually kind of easy, right? Because if I'm outside of the sphere with my Gaussian surface, right? So now this is R. Now my Q enclosed is not changing, right? So as I go further and further out away from the charged sphere, I don't enclose more charge. My charge enclosed is just what the total charge is on this thing. And we can figure out the total charge on that thing from here. Remember that Q enclosed was equal to this. So Q total is just 4 pi rho times big R. Because we're figuring out the charge enclosed when R, the radius, is now at big R. Okay? But my electric field is being measured at R's that are further than big R. So we have E times 4 pi little r squared is equal to Q total over epsilon naught. That's equal to 4 pi rho big R over epsilon naught. Four pi's cancel. And then so now you're left with E is equal to rho R over r squared epsilon naught. Little r squared epsilon naught, yeah. And that should be it. This is physics. Yeah, and this is the whole thing. Outside is the easiest. Although you still had to do the integral, though, Sasha. You still had to do the integral to figure it out. Yeah. Does that make sense, Nicola? And then here, I'll save all this for you. I think what you did made a lot more sense than my TA. Fuck yeah. Love it. I mean, sufficient to say, I mean, I have 20 years of teaching experience. Your TA probably has a year. Maybe 2. Also, they're an overworked and underpaid graduate student, so, yeah. I'm glad it makes more sense to you. Sick! Okay. Let me help out some of the other ones on the queue, and then I'll come back and do the next one, your other one for you, if you want. What was my GPA in high school? I don't know. I was ranked... Fuck, what rank? I think I was 13th. 13th out of 600. Yeah, I know I was top 3%. Top 3.1% of my class. That's what it was, top 3.1. But I'm by no way, I'm in no means like the smartest person out there. A 3.94 GPA? Yeah, so high school GPA is weird because it's not weighted the same. Like AP classes, for instance, in my high school were worth 6. Being smart is subjective. I agree with that, River, as well. Yeah. You know, if you ask a fish whether it's smart and you judge it by whether it can climb a tree, it's gonna think it's like the dumbest fucking thing on the planet. You know. If you ask a fish if it's smart based on how much it can swim, it's gonna do better than like a, I don't know, better than a bird. Birds can't really swim. About the sphere question, was there another method? No, that's kind of the only way you can do it. Did you get a scholarship to UCLA, or was it your goal, always your goal to go to UCLA? And if you didn't get a scholarship, do you still have student debts? I went to UT for my undergrad, and because that's in-state tuition, I think it was only like 10 grand a year. And I was fortunate enough, my parents paid for that. So they paid whatever, the 30, 40 grand for me to go to UT for 4 years. So that was really nice of them. UCLA, I went to do my PhD. They pay you to go do your PhD. Well, really what they do is they force you to work as a TA, and then that pays for your tuition. So you don't have to pay money to go to grad school as long as it's a PhD, and they definitely make you pay for masters. But if you're on a PhD program, they don't make you pay, and it has to be something like STEM related. It has to be something with funding in order for them to justify paying you. Okay, this question was from HH. I have no clue what this is, but it says, for the following set of functions, final terms that can be used in a minimum 2-level and or system using the Quine-McCluskey method. The fuck is this? My PhD was in plasma physics. You do get paid to get a PhD. You don't get paid very much. I think I got about like 35 grand a year. It's barely enough to live. And for that reason, that's why I started tutoring a lot in grad school. Because LA is not cheap. I'm throwing this in ChatGPT because I have no clue what Klein-McCluskey is. I don't know what the Quine-McCluskey method is. Yeah. Is it like work experience or is it like classes? You definitely take classes in grad school, yeah. I mean, some of it's work, I guess. Work experience. Okay, wait. Implementing the Quine-McCluskey method with Python. Oh my god, what's happening here?
That's dope.
What is happening? The PhD is classes for the first 2 years, and then it's basically lab experience for the next, in my case, 7. But usually it's another 5. I took a little bit longer because my projects got switched halfway through. Also, COVID happened, and like no one wanted to do shit during COVID. Jeff says, what the fuck is this? Yeah, exactly, bro. Dude, if Jeff is saying what the fuck is this, then I know I'm already like kind of screwed. Yes, Jake, I can see your messages. I don't know who Albina Tropina is. That sounds like a meme name. Dude, River, dude, that's my favorite quote. 50% of people are below average. I love that quote. I can't believe, yeah, I love that quote. That's a fun one. Okay, I don't know about this question. I'm gonna help Thum out, because Thum is next. And we'll let ChatGPT like keep going at it on whatever this is. I don't know what prime implicants and min terms are. Yeah. Okay. Well, there's your answer, dude. I have no clue what this means. What is love? Baby, don't hurt me. Don't hurt me. The second screenshot's the one you want? But the second one isn't using Rolle's theorem or anything. Jesus loves you. Thank you. I need a little bit more Christ in my life, honestly. You need to know about extrema on an interval before rolls, and I mean, kind of, not really. I mean, okay, here it says the critical numbers. So critical numbers are where the derivative is 0 or like undefined, right? So, what's up, Thuma? Yeah, you can come speak.
Hello.
What's up, Thuma? What's crack-a-lackin'?
Not much, man.
All right. Yeah, so critical numbers, this is like finding mins and maxes of functions, yeah? Because all of these things, like relative maximums, relative minimums, absolute max, absolute minimums, these occur at critical numbers. And critical numbers are defined as, I believe, where the derivative is 0 or where the derivative is undefined. Yeah.
So we're
Taco
supposed
Cat,
to
you-
find the critical numbers?
Yeah, so the critical number I think is here. I think it's x equals 3. And then also technically x equals 2 and x equals 5, I guess. Or x equals 4, sorry. So you want to figure out where the derivative would be 0? The derivative would be 0 here, right? Because that's where the tangent line is flat. Do you know the concept of like tangent lines? It's okay if you don't.
Kinda?
Okay. So tangent lines, Thuma, kind of describe like where the function is going, okay? So like if I look here, right? The function looks like it's going that way, yeah?
Right.
Here the function looks like it's going this way. Here the function looks like it's going this way. That's how I kind of like think of tangent lines.
Like the slope.
It's like the slope. It's the instantaneous slope. Yeah, exactly. This is a good little demonstration. So these are like, so the blue line here, for instance, is the tangent line. Thanks, River.
Uh-huh.
And the black is like marking where we're looking at the tangent line, so like where the slope is. So notice how like here, right? So we're on the left, because the black line's on the left. That's where the slope is basically 0, right? Because it's basically flat, okay? And then as we go to the right, look at that blue line, right? It starts to go up, 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 because that shows the function is increasing, increasing. And then eventually it's just like basically a horizontal line. So those are cases of the slope. I think we always count the endpoints as critical points, because like we don't know what happens at the endpoints, especially when it's an open circle. That means like it can't equal this, which means it's discontinuous. So the critical numbers, it's weird they call it the critical numbers. Usually we call it the critical values, but I would say like 3 and then 2 and 4 maybe, right?
Mhm.
Okay. So then it says describe what like phenomena is happening at the critical numbers, okay? So at x equals 3, you definitely have a max, right? And if you don't know whether it's the biggest max yet, you can always say it's a relative max. So I would say, cool, there's a relative max at 3. You don't really have any relative minimas, because relative minimas occur when this happens, when you have like a U shape. So when the slope goes from being up to being flat to being down, which is also written as like positive, 0, negative. And the slope is also the same thing as the derivative, right? You know the slope is also like the same thing as the derivative of a function?
Yes.
Good. So when the derivative goes positive, 0, minus, this is called a relative max. And then we have to classify it further to find out whether it's the absolute max. But for now, it's the relative, okay?
So it does not exist.
Well, so, okay. So for minima, right? Minima, I believe, occur when the slope goes from down to 0 to up. So this is negative, 0, positive. That's called a relative minima. Okay, do you see how, because that's going to be like a low point?
Right.
I don't see anywhere on this graph where the derivative goes from down to 0 to up. So I don't think it exists. Jeff in the chat is saying that absolute minima are relative minima. I don't know. That's a thing for the, I don't know, the technical police court or something. Okay,
I
so then
see
we
2
talk
points right there.
for what?
But like they're open circles, so I guess really not.
Well, we don't know what's happening here, right? In order for these
Yeah.
to be minima, again, I need like a U. And I think I need like an upside down U for relative maxima. Now for absolute,
Isn't
absolute.
that
Yeah. What was your question?
I was
You
gonna
good?
say, isn't the top one the absolute maxima?
Exactly. Yes. So it's a relative maxima, and because it's the biggest maxima, it's also the absolute maxima. Cool.
Yes.
Absolute maxima just refers to like what's the maximum value of the function. And a lot of times it is one of the relative minima. It doesn't have to be though. So, for instance, if our function looked something like this, let's say there was like, I don't know, open circle, and then up here, this is the absolute max. And this is
Right.
just a relative max. So this
Anything
shows
in between.
this shows my like I call it like sad face behavior that I want out of a relative maxima. This shows my happy face, which is a relative minima, right?
Mhm.
But then here's the cool thing. All right, let's extend this down actually. So this, for instance, is a relative minima, but the absolute minima is here.
I see.
Yeah.
But it's an open circle.
So Jeff says, my bad, no minima here, open circles. Yeah, then what about like right before it? Yeah, okay.
Like
whatever.
2 point.
Yeah, like what about like
2.1?
2.000000001? Can't be a minima? Okay, whatever. So sure, just say does not exist. I mean, that's some like bullshit, just like math gets tricky with the definitions sometimes, but for all intents and purposes, these are the minimums.
Sure, it exists.
Yeah.
Yeah.
There exists, but it's not at a critical number.
So
Okay.
what if there's those endpoints are filled in?
If they're filled, then they are the absolute minima for sure. But yeah,
So there
those
could be
would be the
two.
absolute minima. Yeah, there would be.
I see.
Wait, no relative minima? Yeah, I don't think there is a relative minima, Jake, because on this thing here, Jake, I don't see any of this. I gotta see derivatives go from negative to 0 to positive. I'm pretty sure. Yeah. Okay. So I mean that's like kind of useful. I like your question about Rolle's theorem. Probably better.
I got the x equals 3, 2, 4 wrong.
Oh, okay, then just say 3.
It's 3.
I don't know if it defined 2 and 4 as being critical. Was it cool with
Oh,
3?
Yeah, that's right.
Yeah, okay.
Yeah, it was cool with 3.
Yeah, it's whatever. There's some like technical thing about this being open. Yeah.
You have time for the other one or no?
Yeah, let me do it. I'll do it. Yeah, you're good. All right, explain why Rolle's theorem does not apply to a function even though there exists an a, b such that f of a equals f of b. Okay, so Rolle's theorem is a special case of the mean value theorem, which what the mean value theorem says is that if I have a function that is continuous, okay, so let's say like this, okay, and it has, let's say, some x is equal to b. So then y is equal to f of b, right? And then there's another point here. Which is, for instance, like x is equal to a. Oh, thank you, Jake. Jake likes my handwriting. W, dude. Then this is y equals f of a. Okay. As long as the function is continuous, okay, that means there's no breaks, nothing happening, okay? There must exist some point in between at c, okay, such that the derivative there is equal to the average derivative between a and b. And the average derivative is also called the secant line. So this right here is what I call like the average derivative. But I think they also call it the secant line. Yeah.
So I have a question. So what does it mean? Because like I know you have to have three things that are true. Like it has to be continuous, it has to be differentiable,
Yes.
and f of a has to be equal f of b. But the last part.
No. The last part is a special condition for rolls, and I'll show you why it is. Okay.
Right.
This is the general MVT, which just needs the first two requirements. Okay.
Oh, okay.
Okay. And so what that says is that the slope, which is the secant line between point A and point B, that slope needs to pop up again somewhere in between as the derivative. And that pops up here, right? So for instance, f prime of c here is equal to the slope of the secant line between A and B. And the slope of the secant line, right? That would be y2 minus y1. So, right, that would be f of b minus f of a over x2 minus x1. Yeah?
Is this the limit?
Not a limit. This is just what the MVT says. So, the slope of the function, that's f prime, at some x coordinate c, yeah, has to equal to, like, the average slope between point A and point B. And the slope between point A and point B is the same thing as like y2 minus y1 over x2 minus x1. I know it looks like the limit definition of a derivative. I know it looks like it.
Uh-huh. Yeah, it does kind of...
Yeah. Well, because what the limit definition of a derivative does is it takes the limit as like b here gets very close to a.
Oh,
So
yeah,
for instance,
true.
if you take this point here and you get it really, really close to a, then you get the instantaneous slope, which is the derivative, right?
Yeah.
Okay. So now let's consider the case of we're doing the MVT theorem again, but let's consider that f of b is equal to f of a. What would that mean that my average slope would now be equal to? Just thinking about math-wise, right? So it's this over this. What happens if this equals this? What do you get?
You get one slope?
You get 0.
Wait. Oh.
Right?
If it's equal, you get 0. This is really confusing.
I'm getting it for you.
I don't think I went... Yeah.
Let me get it for
I
you.
didn't
Watch
go
this.
through this one a lot.
Okay. So this is B, this is A, this is B, right? So then this right here is f of A. But that's also equal to f of B. Right?
Right.
Okay. So now, what's the average slope between these 2 points?
It's 0.
It's 0, okay? So, since the average slope between the 2 points is 0, there has to exist another point in between where the derivative is also equal to 0. And that happens here.
Oh, I see what you're saying. So if they're both the same,
Mhm.
which makes it a constant, the center, like everything in between has to be 0 as well. Like the
Not
slope.
everything, but there has to be at least one point, at least one in between the two that also has the derivative equaling to 0.
At least one, yeah.
Right? And when the derivative is equal to 0, that's a critical point. So this is how you can show that there has to be either a local max or a local min in between point A and point B.
Right.
Yeah.
What is it looking for? Like I get what it's saying and what it means. But
Mhm.
like the Rolle's theorem and the mean value, like I know what the Extrema one was asking for. It was asking for like the critical points so you can find
Yeah.
like the min or max. But this one
So
is
what the MVT is doing is telling you it's more of like a proof tool is what it is. It's telling you that you can prove via these theorems that there needs to be a max or a min in between those 2 points. Because sometimes this equation here, Thuma, will be just ugly as fuck. And like there's no way to take derivatives and figure out where it's equal to 0. But if you can prove that the function is the same at 2 outside points, then you know there has to be a max or min somewhere in between there. So it's more of a proof thing.
that makes sense.
Yeah. So yeah. So if f of b equals f of a, this goes away. This is 0, and so the derivative has to equal 0 somewhere.
Right.
So in this question, I don't know what the fucking cotangent of 9 pi over 2 is. What is it? Ugh. One sec. Well, okay, first of all, cotangent is continuous. Is it? No.
Let me
No, it's
check it
not.
up.
It's not continuous. Tangent's not cotangent. Wait, is it? Is cotangent continuous?
It says no.
Yeah,
Not
cotangent's not. No. Because it does like this is what it does. So it jumps. Yeah. Actually, yeah, wait. One sec. I gotta take a phone call. I'll be right back in like 3 minutes. Is that cool? Can you hang around just for like
Yes,
3 minutes?
sir.
Cool. All right.
Yes, sir. It's Calc 1, Walgreens, dude. Oh no, he's just saying like I don't understand it, and I'm just telling him it's Calc 1. Maybe he's not there yet. Are you a high school student? So you're probably in like pre-calc. Yeah, you sound pretty smart, so you sound like you're ahead. Yeah, that's I encourage that, bro. Like self-learning, it's probably like the best thing you can do for yourself, like academically. Yeah. No, yeah, that's a big problem. It's I feel like it's more of like a business when you get to like university, college, like they want you to take those classes so that way you can, they can get paid, and in return you get your degree.
All right, there we go. How can I submit my questions? There's a website. Go check it out. All right, Thuma, let's see what the rest of this question was. This is it. Yeah. Okay, so this is not continuous, just because cotangent looks really weird. Yeah, so not continuous. Which means it's not differentiable, right? It's not differentiable at certain points, I think. Wait, do we have to select all that apply?
Anything in between pi and 9 pi. So it's a closed interval.
So I think not differentiable. This is false. It can equal. It can't equal itself. Yeah, if it's discontinuous, it's not differentiable either, right? I agree with that. Oh, so then this is true. Or this is like bad. Thank you. Yeah, River showed a picture of cotangent. Let me pull it up real quick. Thanks, River. Yeah, you can't take the derivatives, yeah. I had to sneeze. So yeah, and then this is true. The derivative does equal f prime of a does equal f prime of b in certain places. Thank you, Jake. So I think it's just b and d. Gesundheit, yeah.
Okay, let me
I
check.
think that should be it. Is that right?
Testing. Yeah, it's right.
Nice. Love it.
Thank you, sir.
You're so welcome, Philo. Thanks for the question. That's really cool. I'll get you a point for that.
Yay!
Woo! What are you at? You're at 1 point. Oh, did you just join our server? You know you get points just for like following and stuff. Like, it's a very easy way to.
I was here since AFG was here.
Oh, okay, nice. Okay, cool. Where's AFG? I haven't seen him in a while.
Oh, he's been really busy. Like he has lots of tests. Like he takes AP classes and everything, and he does a bunch of stuff. So I don't know. He's really smart. So I ask him for help a lot.
Okay. Well, yeah, you're more than welcome to ask for help here too. And if he gets kind of stuck with his AP stuff, remind him that like I'm still here to help him.
Yeah.
Okay. Sick. Good question, Tuma. Thanks, man.
Sir.
Someone said, can you quickly remind me of what Rolle's theorem is? Yeah, so we did that a little bit earlier, but Rolle's theorem just says if you have a function that's continuous, which means it doesn't break or anything like this pink one here, and you have the function equaling the same y value at two different spots, then there has to be somewhere in between these two spots where the derivative of that function is equal to 0, because the slope somewhere in between has to equal the average slope between the 2 points. Kind of what it means. This is calculus, which could be like 10th grade, maybe 11th, maybe 12th. The inverse of a matrix. Yeah, submit a question, I'll do it. 3x3s are a little tricky. There's a couple different methods to do it. You can do something with like transforms and things, but... Okay, nice. Good. Oh, nice. H8's return. Okay, let's see. What's the Q at so far? Let me see. I did one of Nicola's, right? So I can mark that one off. 1 second. Cool. And then we did... wait 1 second. Let me clear that. Mark. Done. And then we did Thuma's. Wow. Lots of other ones. Let me see. HH. What did you submit to me, River? What is this? What was this? Was this from yesterday? Oh, that's River. Okay. Yeah, what is this? What do you want to show me with this? What's the question? I mean, I love learning things with you. It's fun. If you want to submit a general question or anything else, yeah, rational functions, there's a website right down there, actualdiscord.com/submit. That has a way for you to drop screenshots in, and I'll go over 'em. Okay. Oh, wait, sorry. Let me boost your volume. All right. Boost your gain on your mic a little bit, River.
Let me see. I don't know how you do that.
I think in settings.
Close to the mic.
Yeah, be close. You gotta be really close like this.
All right.
Okay.
I usually don't because sometimes you can hear my breathing.
It's okay. It's ASMR River.
So, I was in class and I was playing with parametrics and I was like, what do you do with them?
Okay.
Because
Like, why are they useful and stuff?
the question I have is there a function, like, can you take the derivative of this as it, say, W increases?
Yeah. Yeah, you totally can. Yeah. Let me think. Derivative of a parametric function. Isn't that just... One sec. I remember. Yeah, I think it's a chain rule. Is it not just a chain rule, Jeff? Let me see. It is just a chain rule. Okay, cool. Yeah, so the most simple example of a parametric function, right? And the reason why we use parametric functions is sometimes we want to restrict like the path something can be on, right? So, for instance, if I want to describe the path of a race car, right? It's not a chain rule. Jake says it's not a chain rule. Well, maybe it's not. Well, let's see. Let's see. Okay. So let's say I have a person who's racing, and they just need to stay. Oh, it is a chain rule. Yeah. They need to stay on this track, okay, which has let's say a radius of, I don't know, let's say like 5 miles, okay. Kind of similar to what you have here. Well, not here. Sorry. Where is it? Here, right? This is another. This is a track. I mean, this is like a really scary like Mario Kart track or something. But you can describe, right, the path of something in terms of like a function, and then what the parametric function does is it says, okay, now I can describe where you are along that path in terms of another parameter or another variable. So in this case, let's say you're on a racetrack with a radius of 5 miles. That is fixing you to this equation, right? You need your x squared plus your y squared to be equal to 25, right? That's like the equation of the path that you're along. Now, let's say, for instance, I want to describe where I am along this path at different times t, right? Okay. So one way to parameterize this would be like, okay, I'm going to think about this as like x is now a function of t, and x of t in this case will have something as a function of t, and then y will have something as a function of t. Yeah, so polar coordinates is a simple example of a parameterization, a parametric function. We learn with polar coordinates that the best way to describe where something is in the x terms can be in terms of an angle, right? And that x is equal to, in this case, 5 cosine theta, and then y of theta is equal to 5 sine theta, okay? And what that means is, like, as I increase theta, right, my position along this track changes as well, right? But I stay locked to this position, like to these. I stay locked to this function, but where I am along the function is now parameterized by something else. In this case, it's theta. You can replace the theta with a t. I can say, cool, well, okay, x of t is going to equal to 5 cosine of t, and y of t is going to equal to 5 sine of t. Okay? So then, if we wanted to then figure out, like how fast I'm moving, which would be, for instance, the derivative of this, so like dx dt. Thanks for the falls, by the way. Wow, we hit 1900 today. Nice. Super sick. Right. Yeah.
So I just don't know the notation for the ext.
Yeah. Well, no. So here's what usually wants to happen. Usually, what you would want to find, for instance, is if you wanted to figure out like dy dx, like the derivative of this function, being bound to here, right? This would be the same thing as dy dt over dx dt. Okay? Which is the same thing as, yeah, right? What, dy dt times dt dx? Yeah? That's like one of the chain rule things you can do. Yeah.
Yeah, I think.
And then let me think how you would also do this. Yes, and then you do the product rule of y equals r cosine theta sine theta. Let me think though. Well, it's not really a product rule. So dy dt in this case would just be equal to, I think it's cotangent t times a constant, right? Because dy dt is just going to be 5 cosine of t, and then dx dt would be equal to negative 5 sine of t, and then sorry, this is dy dt, and then this is dx dt. And then so dy dx is this divided by this, right? Which is going to be negative, I think it's negative cotangent of t, Jeff. Well, we do know r. We said r was equal to 5. But sometimes r is also a function, right? R is not constant. Yeah. I don't think like why this is like really cool though. I'm trying to think. What's up, Canalito? -1 is a constant. Yeah. Do it for an ellipse. Oh, I see. Oh, so this is cool. Do you see this, River? I can now calculate, right, what the tangent line is anywhere along this circle. Oh, that's cool. By doing the parameterization. So in the Cartesian space, right, derivative the derivative of the slope of the tangent line, which is the derivative of the function, needs to be dy over dx. But that's kind of hard to do from this point of view, right? If I wanted to write this as a function, this would be y is equal to, what is that, 25 minus x squared square rooted, yeah?
Yeah.
And then so dy dx, what would that be equal to? Plus or minus. Yeah. So it's discontinuous, first off. But let's just say just for the top. I'm just curious. So dy dx would be equal to, you know, from the chain rule, that's 1/2 25 minus x squared to the minus 1/2 times 2x. Do you understand this part? How I got from here to here? I forget what your math background is, like how much calculus you know.
I know derivatives pretty well, at least the basic rules.
Good. Okay. So what's up, Callum? So okay. So that's equal to oh, that's just x over the square root of 25 minus x squared. Okay. That's equal to dy dx. Oh, I think I see something really cool here, actually. You can also do negative cotangent t, but replace t with a cosine x5, but don't. It's not 2x, it's minus 2x technically. Sorry. Thank you, Kute. Yes, exactly. Thank you, Lukuch. Yeah. Sorry, I forgot the minus here. Okay. So this is dy dx as a function of x, right? And then if you want to double check that this is true, you can say, okay, well, x was equal to 5 cosine t, right? And then let's see what happens when you plug that in. So then I get negative 5 cosine of t all over the square root of 25 minus 25 cosine squared of t, yeah? If I plug this back in. So then this becomes negative 5 cosine of t over, you can pull the 25 out as just a 5. And this is square root of 1 minus cosine squared t. And then, River, do you know what 1 minus cosine squared is?
I don't know the trig rules.
Oh, you should know these. No, River, we need to know these. There's only 2 you really need to know. Sine squared plus cosine squared is equal to 1. And then 1 plus... Fuck. Is it 1 plus tangent squared is secant squared? Secant squared, maybe? I think this is right. Or is it 1 plus secant squared is tangent squared? Someone tell me whatever. Someone just type in the chat, please. That's correct. Okay, so here's the cool thing. 1 minus cosine squared. So look what happens, River. If I move this over, I get sine squared is equal to 1 minus cosine squared. So this becomes sine squared. This becomes -1. So now I have negative cosine of t over the square root of sine squared t, which is equal to negative cosine of t over sine t. And that's going to be equal to negative cotangent of t, which is the exact same result we got from here. But I feel like this was a nicer derivative.
Good job.
Right?
Yeah, I didn't know they were the sine and cosine rules.
Oh yeah, no, yeah. These are really good things. If you want to do well in math, River, like the more trig identities you know, the better you'll do. There's a lot of trig that comes in. Trig identities is my funeral. Yeah. The Tesla person's right, dude. I know you guys hate trig identities, but they come in handy. I'm sorry. Is this tangent acceleration? Well, is dy dx. So, I mean, that's... I think tangent acceleration would be the square root of dx dt squared plus dy dt squared. I think this is v tangential. I enjoy trig. I enjoy trig too. No way I'm covering this right now. What a coincidence. Dude, the algorithm knows, bro. But yeah, someone else also said a really good thing here, River. They said that parameterization comes up a lot in Calc 3. And I totally agree with that. So Calculus 1 is usually like derivatives. Calc 2 is like integrals and maybe some series. And then Calc 3 is like all vectors, multivariable, parameterization. So it really helps to kind of get good at doing parameterization eventually. It's just polar coordinates is like the simplest example of what a nice parameterization is. Yeah?
Yeah.
Cool.
Do you know the function?
Pardon?
Do you know the integral function? Like, I know how you approximate a derivative and how you solve for it.
Sure.
But I don't know the one for integrals.
So the one for integrals is the Riemann sum is what it is, right? I'm just gonna get a picture of it rather than write it all out. Someone's got to have a nice diagram of this. Come on, guys. And what? All these diagrams suck. Add it to the list of things I need to create. Man, someone. This is where I'm like, someone should be doing this. But okay. Here. Let me copy this image in. Lebesgue integral. Yeah, we don't really need to do. So the limit definition of derivatives does come in handy sometimes when you can't use derivative rules. I'm not so sure the limit definition of integrals gets used that much, right? I think we kind of just I mean, it's a good way to interpret them, I guess, but we kind of just like skip ahead to it. So this is like the definition of an integral, okay? Is you're taking the limit of basically creating a ton of these little rectangles and finding the area of those rectangles. So area, right, is always equal to like base times height. In this case, this is the base. And this right here is the height. Okay? Where x star is referring to like which like which nth term are you looking to? And what you figure out is that as you have more and more of these rectangles, you get closer and closer to like what the actual area is underneath. And so taking the limit to infinity is the same thing as an integral. Yeah. That's a cool one though. I mean, that comes up sometimes in classes.
Whenever it goes under the x-axis.
Yes. Yeah, under the x-axis. Nice. Okay, let me move on. I got the queues now at 13. Wow, you guys are submitting a lot of questions today. I love this, but I like this, River. This is cool. Please, yeah, always ask me like little like math exploratory things. It challenges me to really understand what the basics of these things are and like how to explain them, and I enjoy it. It teaches me things.
Thank you.
Cool, you're welcome. Okay, Puma says, what do I do with bond coins? You can buy gift cards. Yeah, we run a Discord. We give out gift cards to students who do well in their classes. So, and if you ask questions, yeah, Lots of fun stuff. Okay. Let me see what the queue's at. The queue's quite big today. Which I'm happy. I'm happy with a lot of questions. All right, so we just did. Also, why do I not see Rivers on there? Okay. Let me see if Odin's here, and then Nicola, I'll do yours because you've been waiting for almost an hour and a half. And then I'll go down to do the other ones. Did Thuma have more? No, I did. I don't know why the order's fucked up on it. Oh, there it is. Yeah. I can definitely help with your homework. Jake, you submitted something, right? Here, I'm just going to show like everything that's in my queue already. Where's my... Come on, Discord. There we go. Yeah. So, I see Jamie's question. Jamie, if you're here. I see Chloe's. I see... Oh, Nicola, you just sent... You sent me like what they did already. Okay. And then I have HH's return, and then... The energy method. Jake, what is this? What is this? The energy method. Yeah. Good luck, Darian. Yeah. So I'm just going to put a bunch here on the board, and then someone scream at me if like this is your question. Oh, okay, cool. Oh, is he using Kudu for his homework, by the way? Nicola, is he using Kudu? And then this is a good one too. He is. Okay, interesting. The Kudu homework should be easier. The cement bag. Oh, I see yours. Yeah, I see it. I see this. Okay, cool. All right. Luckily, I have another 2 hours I can stream, so I will get to all these. You just gotta hang around, if that's cool. Let me do Jake's, and then I'll do one of Nicola's really quick ones, and then I can do this Odin, and then Jose. I see you have some ones too. This is good. These are all good. Yeah, look at all these questions we got. Yeah. Find the inverse of this matrix. Oh my god, dude! I'm just gonna show you all the questions I have that have been. I love this. By the way, I thank you guys, everyone, for submitting these. This is where, dude, I need Jeff. I need you to start streaming so you can handle some of these. The first one looks like a nightmare. Yeah, Jake, if you gave me a nightmare question, I might punt on it, just in the interest of time. Wait, was that a PDE? Oh, what's up? Zach's here. Yeah, Zach saved the day, maybe. You want to test my ability? Okay, but don't test my ability when other students are like needing help for their exams. I love you, Jake, but like, yeah, don't do that to me. If you want to test the abilities, you should go test the abilities of either 2i Pi. Oh, I also just need your help. Okay, that's fine. All right. Yeah. No, some people definitely just submit to me like ridiculously difficult questions because they want to troll me on YouTube, and whatever, it's funny, but I don't get mad if I punt because I have to actually help people. And then Chloe says, with my linear algebra one, yes. So that's this one, the basis. I see that one as well. I see so many questions. And then Jamie's as well. Jamie, wherever you are. How hard is the SAT? SAT is pretty easy, dude. Okay, so here we go. We got a lot of these. A lot of these coming up. Nice. Thanks for the follow, dude. Appreciate that. Smooth Space Oddity. Wow. Okay. Let's try to help Jake with this. Oh, can you look over it to see if he overcomplicated it? Yeah. Let me take a quick look at it real quick. Wait, why is he doing a cylinder? Sorry. Oh, the third one down I did yesterday. Can we do Jamie's question? One sec. Let me just for Nikola real quick. Yeah, this is too hard. I don't know why he's doing all this. Doesn't need to do this. This is too much. You don't need to start doing things in spherical coordinates. This is pretty standard though. I'm cool with this. No. You don't need to do this. That's too much. And I don't know what the fuck is going on here. He's being rigorous. That's what he's doing. He's being rigorous about it, but you don't have to. I mean, I hope the way I showed you how to do it was a little bit nicer. It's just, yeah, it's about, you know what, it's called calibrating, you know? If you go up to someone and you just instantly start saying like, hey, I want to marry you, you're not going to get a coffee date, you know? Like, you got to calibrate. You got to calibrate. Physicists not being rigorous. Yes, Gauss's law is like relatively simple. Okay, assume the following equation has a smooth solution. Jesus Christ. Okay, equals sine x. T of A is equal to that. T of B is equal to that. X is contained in the set of A and B where T is greater than 0 and B is greater than A. Prove that the solution is unique by using the energy method. I have no clue what the energy method is. Is this physics? Physics has energy. Is there an energy method, Zach, in DiffyQ? Zach says he's seen this before. Zach is my resident math expert. This is a partial differential equation. Oh, okay. I never took partial differential equations. I took differential equations. I know DiffyQ. I don't think I ever took PDEs. Joe says I'm in DiffyQ and I've never seen this. I agree. Okay. All right. So, Jake, yeah. I'm already also looking at, like, what ChatGPT says, and I don't recognize any of this. If I didn't already have 14 people with questions, I would go through this and learn it with you. But I don't really have the time for that. But yes. Oh, it is kinetic energy. That's cool. And Femvox says no idea. Okay, so yeah, you have 3 of my resident math experts saying they have no clue how to do this one. So I'm unfortunately gonna have to punt on this one. Just in the interest of time. I want to make sure I can help people I can actually do things with. But Jake, I will say this. If you want to learn this type of stuff, I have other friends that stream at a much higher level of math than I do. I top out at like DiffyQ. PDEs, not so much. But yes, I can do probability and statistics all day. I love those things too. If you go to the website and then you go, I don't know measure theory. And if you go to the streaming schedule here, click, you can see when our other friends are streaming. So, Zach is going to have a math and math education Q&A. Yeah. I know sadness, but just because I can't do it doesn't mean there aren't people that can. And so I really invite you to go check out Zach's stream tomorrow. Again, if you're asking about measure theory, partial differential equations, like all these like really, really high math topics, we have friends that do those things. Because my PhD is in physics. His PhD is in math. So he understands more math than I do. And he's a great guy. So go check out Zach's stream tomorrow. It's at 11 a.m. Pacific. And I'm sure he would be more than happy to go through that type of question with you. Yeah. Let me see. Me when the homework is due tonight. Oh, I'm sorry. Well, here, do you want the ChatGPT link, Jake? I'll give you the ChatGPT link for what they said. Input on the paper you're developing. Ooh, I don't know about that. Here you go. I'm gonna copy this for you. Wait, that was the prime implicants, dude. Where was it? Oh, stop. This was it. This is something with like homogeneous boundaries and like whatever's going on. I'm not exactly sure what's happening here. But if you're in our Discord, Jake, which I recommend you join, let me know what your username is. I'll tag you, and then there's a link to using my fancy version of paid ChatGPT to help you. Tutoring equals asking ChatGPT. It does sometimes. No. Well, sometimes when I don't understand what the thing is, in the case of it being partial differential equations. That's the best I can do. And, you know, I will admit, I'm human, right? I don't know everything. Okay, let me do, what was the easy one of yours, Nicolas? I can do that really easy. This one? Because I know you have a test coming up tomorrow. You enjoy the physics? Yeah. I can do the physics all day. Is there more tutoring resources on the Discord? You can post questions, and if there are people on my Discord who do just like go through and solve them, yeah. ChatGPT Pro is the best thing you can give an engineer, yeah. Okay, this one. Okay, let me do this question real quick, and then we'll see what else is on the list. I think HH here probably next. All right, so let's see. What is the direction and the magnitude of the net force on charge Q1? Okay, cool. So they want to know the force on this. Okay, so force. So the cool thing here, okay, these are the same charge. That's nice. It's just adding up all the KQQ over R squareds is what it is. So, for instance, you can do F21. Yes, Chloe, I can. I saw yours. Yeah, I'll do it. F21 is K, and then that's going to be 1 times 10 to the minus 6. 1 times 10 to the minus 6 over R squared, which is just 1 squared. And then because these are they all the same charge? Yeah, this is positive. This is positive. Okay, so, and this is positive. So the same charge means that it's going to push the first one to the left. So I'm going to say this is in the negative x hat direction. Okay? And then that's also going to be the same as the force between Q3 and Q1. So we can say force 3 on 1. That's going to be equal to the same numbers. However, that's going to push it up in the positive y hat direction. Also, yeah, if you're watching on my stream and you want to see what the original screenshot was for someone's question, you can click on the name. So, for instance, if you want to see, whose was it? Was it Jake's? Yeah, you can click here on Jake, and it'll show you what the screenshot was. So, if you go to actualdiscord.com/submit, and then you go here to the live queue, click on live queue, you can see screenshots of everybody's questions. If you want to like kind of follow along. Yeah, for a sec. Yeah, no, they don't. Yeah. So this one pushes up in the y hat. This one pushes left in the negative x hat. And then this is cool. The force between these two, Nicola, right? This is a negative charge. This is a positive charge. This is going to pull this one this way, okay? So I can say that F41 is equal to K. I'm not going to put the negatives on things for now. And that's going to be 2 times 10 to the minus 6. 1 times 10 to the minus 6. And then we need to know the distance of this, okay? So this is where, like, the Pythagorean theorem... Oh, sorry. Thank you. Wrong screen. Sorry. Wrong screen. Sorry. Sorry, Nicola. I got so occupied. Yeah, you're okay. All right, so here we go. Sorry. This one, right, between these two, that pushes it up. This one pushes it to the left. This one is negative. This one is positive, so it's going to pull it this way. But I'll deal with that in a second. I'm just going to figure out what the magnitude of the force is. And so that's K, Q1, Q2. And then we need to know the R. We need to know the distance R here, right? This is a right triangle. If this is 1, this is 1. 1 squared plus 1 squared equals c squared. This is going to equal the square root of 2. And so that's going to be over the square root of 2 squared. And then it's interesting. That's pointing... directly diagonally down, okay? If I want to get the components of this, okay? Because it points this way, right? We can kind of think of this as, I don't know. like maybe some angles here. Let's call this like the angle. I know that this is going to be 45 degrees, Nicola, because this is the same distance as this. This is an isosceles triangle. If this is an isosceles triangle, this is 45 degrees. This is physics. So, this is the magnitude of the force, right? But if I want to know the component, right? Well, in the x-hat direction, that's going to be sine of 45 degrees. So I would say this, sine of 45 degrees in the x-hat direction. And then it's equal... college physics, yep. And then we would say plus this times the cosine of 45 degrees in the negative y-hat direction. Okay? Reason for this, okay. If I know this is like, for instance, f41, then this part right here, f41x, is equal to f41 sine theta. And then this is equal to f41y, which is equal to negative f41 cosine theta. Turns out you don't really care whether it's sine or cosine because we're dealing with 45 degrees. So, because the sine of 45 and the cosine of 45 are the same. But that won't always be the case. Okay. The next step is... So, Nicola, just quick checking. Do you understand this so far? And then why I put these components to break it up into x hat and y hat? Not really. Okay. All right. Fuck. Whatever. Let's just leave this for now. Okay. Sometimes it helps if I just give numbers for things. Let me just give numbers. Because this... I know. I know this can get confusing. I can do redox, yeah. You could. Yeah, no. I did calculus and physics at the same time. You can totally do it. Don't do it over the summer, though. Okay. Does this make sense so far? Do we understand how to calculate the forces between each of the charges? Okay, good. Okay. So let me come up. Let me just get a number for this real quick, okay? Because I know what happens. You see all this shit, and it's scary. So let me just come up with a number real quick. All right. So that's 9e to the 9 times 2e to the minus 6 times 1e to the minus 6 divided by 2. So that's 0.009. Okay. So this is 0.009 newtons. Okay. But the issue is that this does not point in just the x direction or the y direction, right? So when we looked at the force between 1 and 2, right? That pointed just in the x direction. For this one, 1 and 3, that just pointed in the y direction. So now if we're dealing between 4 and 1, that's a diagonal force. So I need to break that up into components. And so what I know is that if my F41 is pointing this way, down, straight down to the other diagonal, okay? It's going to have an X and a Y component to it, right? So it'll have this, which I'm going to call F41Y. And then, let's get a different color. This right here is going to be F41X, okay? We've done this, right? In mechanics. We take a vector, like a velocity or something, that's pointing diagonally, and we break it up into individual X and Y components. So, this is a right triangle. Right triangles mean I can do trig functions. And I know what this angle is. I know this angle here is 45 degrees because it's the diagonal of a cube, or of a square, sorry. Also, I know this distance is the same as this distance, right? They said this is a meter, this is a meter. So that tells me this is 45 degrees. So, F41. So, okay, yeah. Yeah, calculus was made for physics. So let's think about the trig functions. So sine of 45 degrees, okay, we know is going to equal to the opposite over the hypotenuse. The opposite is F41x. And then the hypotenuse is F41. Okay. So then that tells me that F41x, so the component of the force in the x direction for F41 is going to equal, when I multiply this over, F41 sine of 45, okay? And then by the same token, F41y is going to equal to F41 cosine of 45 degrees. Okay? But that y component points down, okay? So I'm going to say, okay, this is technically in the negative y hat direction. And then this is pointing to the right, so that's going to be in the positive x hat direction. Does that make sense so far, Nicola? Does that make sense? How I broke the components for this? That makes more sense. Great. Okay, awesome. Yeah, no, always just tell me if something doesn't. I'll make it work. Okay, so now we have all of our forces. Okay, I have all my forces, and I just need to add them up by components to get like my final force. Okay, so we're gonna take. Well, here, let me write out what this one was. So, okay. Sorry, let me move this. Get rid of that. Well, actually, no, I actually kind of like that. So this was equal to 0.009. Professor, hi, it's TT from UCLA. Oh, what's up, Tita Lope? Are you also struggling with Nicola here in Physics 5C? I'm helping her out. Good to see you. This right here, sine of 45 degrees, this is the same thing as square root of 2 over 2. And then this is also going to be square root of 2 over 2. That's just a trig thing we hope we remember, but it's okay. I understand it's tricky sometimes. Okay, so that's going to be 0.009 times the square root of 2. Your class was so fun. Aw. I appreciate that. Who's teaching 5B? Is it Corbin? This is gonna be Shriver. Oh, I don't know who he is. And this is gonna be in the negative y hat direction. What is 5A? It's a UCLA physics course, Jake. I taught 5A in the spring. That's what I did. Okay. So now what we need to do... he was amazing. Oh. Love it. Let's add all these up. Okay. So now I need to take all of these and get the total. And yeah, 5B is E&M, correct. Well, it's weird at UCLA. 5B and 5C both are E&M. Like, 5B is more the E part, and then 5C is more the M part. Okay, let me also get some numbers just for these really quick. What is this? Is this just gonna be 0.009? Is it? I feel like it is. Yeah. We use an online textbook is what we use. Yeah, wait. 10 to the minus 12, 10 to the minus... Yeah. So this whole thing here is just going to become 0.009. right? And then this is also 0.009. I just know from like 10 to the minus 12 times 10 to the 9 divided by 1. Okay. All right. So we're going to add up all the forces in the x direction, and then we're going to add up all the forces in the y direction, okay? So in the x direction, I have this. I have a minus 0.009. And then I also have a plus 0.009 square root of 2 over 2. Okay? So we took care of this one. We took care of this one. Now let's look in the y direction. The y direction, I have a 0.009, which is in the positive y direction. And then I have a minus 0.009 square root of 2 over 2. Because that was in the down, the minus y direction. Okay. So, my final thing is, right, so total. This is going to be 0.009. And then that's square root of 2 over 2 minus 1. All I'm doing is I'm factoring out the 0.09. And then comma 0.009 square root of 2 over 2. Oh no, 1 minus square root of 2 over 2. Notice how these both have a 0.009 on the outside. So I'm just pulling it out. It would be the same thing. Okay. Final thing is to get numbers, right? So I have, was it square root of 2 divided by 2 minus 1. So that's minus 0.292 times 0.009. So that's going to be negative 0.0026. Okay. And then this, oh, is going to be the same thing. No, it's going to be positive, right? Yeah, this is going to be positive 0.0026. Okay. So the net force should be down and to the right. Wait, is it positive? Wait, I screwed this up. Wait. Yeah, this one's positive. Yeah, Jake, right? Okay. So then the magnitude is equal to the square root of 0.0026 squared plus 0.0026 squared. This is just finding the magnitude of the vector. Yeah, left and up, and I got it, right? Okay. So then, whatever. We do that to the second. We multiply it by 2. Then we take the square root of it. 0.0037. So 0.0037 newtons. And then it's left, right? Because negative x and up. So 0.0037 left and up, which is 3.7 millinewtons, right? So 0.0037. If you divide that by divide that by 1e. Yeah, what's up, Don? Divide that by 1e to the minus 3, you get 3.7. And so, that's the correct answer. Yeah, right? Up and to the left? Is that what we had? Left, up. Yes, cool. Nice, done. We did it. Okay, nice.
Well done! Well done!
What's up, Don? You started streaming early, Don. Did you? Is this like a 6-hour stream you had? I remember seeing some notification at like noon you were on. Let's shout you out, dude. Yeah, good. You're welcome, Nicola. Nice, we did it. Shout out to Don. Don's another great math science streamer. He's in grad school right now, actually. So bless him. Give him prayers. Don did a monster stream. Fuck yeah, dude. What were you doing? Were you doing math, or you were playing DayZ, or what? 6 hours? Yeah, bro. I don't know if I can stream for 6 hours. I cut it at 3. Which, we've only been on for 2. I feel like we've been on for longer. Okay, let me start clearing queues. It was math. It ended up being half homework and half people's questions. Oh, nice. You're doing your own homework. That's great. That would have been fun to see what you're doing. Okay, I did say I would help Chloe out, and then HH, Odin Root, if you're around, you're next. Is that cool? I think we have a linear algebra question. Where does Don stream? Good question. Yeah, so Don streams on Twitch. Wait, this is not my question. Where the fuck did it go? I'll get the link for him. One sec. Let me pull it up. Yeah, Don streams on Twitch. This is him. Twitch. And it's Don Factorial. There we go. So here, I'll post this in my chat for you guys. Here, I'll post this in my chat for you guys. Here, I'll post this. Oh, I'm hearing myself. Uh-oh. Oh, he does. Oh, you do stream on YouTube? Oh, I think you do, Don. You're one of the first people that told me about streaming on YouTube, actually. But yeah, cool. I just sent his link there if you want to check him out. All right, this is Chloe's question. The following statements are all false. Explain why they are false. Yeah, you're the one that kind of got me into dual streaming, Don. Yeah, because I triple stream, or I quad stream now. I do Discord, Twitch, YouTube, and TikTok. It's a lot. Okay. Let T be a linear transformation with the basis on alpha v1, v2 for v. Then transformation v1, v2 is also a basis for w. There you go. Yeah, he's in my YouTube as well. There you go. You've been grad school too? Yeah, commiserate with him. All right. W could be one-dimensional, right? And then Jeff's all saying that the kernel could be not equal to 0. Yeah, right. So what is it again? So if you have a matrix, someone else gave me a matrix at some point. Someone gave me a matrix. Where was it? This matrix, right? So Jake says T could be the 0 function. That's an example. But for instance, if I were to try to find the basis of this matrix, right, wouldn't that be? I don't think any of these are copies of the other ones, right? Wouldn't the basis here be just 1, -1, 3, and then 2, 0, 1? I don't think I see anyone being the other combination of the others, right? 4, 3, -2, and in that case, the kernel is equal to 0, right? But if you had a matrix like this, let's say like 1, 0, 0, 2, 0, 0, 0, 3, 0, this basis would be just equal to 1, 0, 0, and like 0, 1, 0. Yeah, the columns are bases if they're independent. I assume these are independent. And then that means the kernel, I think what you do is you do like x, y, z, right? So that tells me like x plus 2y has to equal 0. And then what is this, like 3z equals 0? Oh, okay. So then the kernel would be 0, and then, I don't know, like 2, -1, right? Is that how this works? Someone make sure I'm doing like good linear algebra. I think I am. How come you don't just augment it with the identity matrix? I don't know what that means. I mean, I know what augment is and I know what identity matrix is, but for doing what? To find the kernel? I think what you do is you set this and you set this equal to like 0, and then you just have to come up with a... Linear algebra was a good subject at college. I used to solve them in Wolfram. Yeah. Oh, to find... yes. Oh, for this one. Yeah, sorry. I wasn't doing this question. Sorry, no. I just wanted to look at the matrix. Yeah, sorry. I'm not finding the inverse. I was just showing for this example here what the basis and what the kernel are. Yeah. Brian, you're totally right. If I wanted to find the inverse of this matrix, I would just augment it with this. And then you do row operations to try to make this look like this, and then whatever turns out here is the inverse. Yeah. Yeah, Ansha says, yeah, kernel is a set that maps the elements to the identity of the codomain. Right, okay. So yeah, in this case, this one was -2, 1, 0 is the kernel. So, Chloe, to answer your question, we say let t be the 0 function. And then, yeah, 0 is not a basis, right? Yeah, 0 has no basis. So if you were to transform your basis here with the 0 function, that's not a basis for W. It doesn't span anything. Span means it doesn't cover any of the numbers. That makes sense, Chloe. Okay, cool. This is a good question. I will go back and do this one. I will actually maybe try to do the inverse matrix. This one might be kind of a bitch. But, Nico says, thank you for your help the last few days. Really appreciate it. I'm going to head out and watch some more videos to feel my security test. I'll definitely be back next week. Yes, good. Yes. Good luck on your test. Let me know how it goes. Okay. Chloe says, okay. Yeah, thank you. Yeah, cool. But yeah, make sure, Chloe, you understand like how to find the basis and the kernel of matrices. This is kind of a useful thing. Yeah, we're not done yet. But okay, cool. All right. Can I do vector spaces? I probably can. What's up, fam? Yeah, and Mean Machine Rex. Is anybody here going to TwitchCon? I will be at TwitchCon this coming weekend. So I was hoping someone would be there. I know some of the other big streamers will be there, but I'm thinking about all my streamer friends here on Twitch, if anyone's gonna be there. Okay, so that was 4 and 8. And then we did this. And then we did 6. Okay. And then I think I did Tumas. Yeah, I did Tumas. Let's get rid of that. I never went to TwitchCon, but I would if I was in San Diego. Yeah. Yeah. That's why I'm going. I mean, I live in Los Angeles, so it's very close for me to go to it. Okay. Let me see if Jamie is here. Jamie submitted this question. If not, I'll do HH's. Yeah. Where is it? Okay. Jamie, if you're in the chat, please let me know. I can do this one. This one doesn't look too bad. It's kind of like a fun little physics question. I'll give like 30 seconds. Otherwise, I'll move forward and do Odin's. No friction. Nice. Yeah. Okay. Ta-da. Let's do this one. This is Odin's. Let's get rid of this. No, that's your username. There we go. Okay. A little bit more math. People want some math. Okay. Find all the local maxima, minima, and saddle points of the function. Okay. I believe what we have to do is we have to find partial x, partial... Right? Partial f, partial x, right? I gotta find df dx. And df dy. Right? Jacobian. Ooh, someone says Jacobian. Okay. Well, okay. Tree diagram for partials. You guys are teaching me some new stuff here. I don't know what the tree diagram for partials is. But okay. Partial f, partial x. So if we do that, that means when taking these derivatives, we only consider what x is. So that's going to be 3x squared plus 3y. Partial f, partial y is equal to 3y squared plus 3x. Oh, that's actually kind of fun. Ooh. That's fun. Okay. Left branch is ddx, right branch is ddy. F of xy equals f of yx. Trying to think what that means. Oh, you're saying the function is symmetric. Oh, I agree with that. Yeah. Okay, it's a symmetric function. Okay. Well, all right. From what I remember from doing one-dimensional types of things, I always need to find critical points, which is where the derivative is equal to 0. So I need this to be equal to 0 in both cases. I notice there's a 3 on each, right? So I can just like pop all the 3's out. Okay. So that tells me x squared plus 3y is equal to 0. Sorry, no. X squared plus y is equal to 0. And then y squared plus x is equal to 0. Uh-huh. So that means that how would we do this? Oh, okay. I'm trying to think like what combination of points do this? Well, if x is equal to 1 and then y is equal to -1, that works, right? For this one? Doesn't really work for this, though. Oh, they both have to be equal to -1. Aha! No, I think -1 is also a solution, Jeff. Right? Yeah. Because, look, -1, -1, and also 0, 0. Okay, cool. So, these are our critical points. And then once we have our critical points, we need to classify them. So in one-dimensional calculus, we do this with the second derivative. However, in 2D calculus or multivariable calculus, we do what's called I think it's called the Hessian. It's the Hessian. Which, remind me, it's like fxx, fxy, fyx, fyy. Is that what it is? Sorry, I gotta look this up. Sorry. Is that the Hessian? And it's like whatever the Hessian is tells us different things. No, I know it's a German. God damn it. Hessian in math. Okay, there we go. Yes. Cool. Alright, so I was right. Wait. I forget. Which one comes first? Oh, so it's dy then dx. So this is fxy. And then it's fyx. Yeah, okay. So I had it right the whole time. Nice. Okay, cool. So, so fxx is going to equal partial x of df dx, which we already had was this. So that's going to be equal to 6x, right? Fyy is going to equal partial y of df dy. And that's going to equal to 6y. I will use the determinant of the Hessian. Okay, is that what it is? Like with the second derivative, if it's positive, right, it's a min. If it's a negative, it's a max. Okay, so then fxy. So that's partial x of df dy. Oh, that's just 3. Oh, and the other one's just 3 too. Oh, okay, so fyx is equal to partial y of partial f partial x. That's equal to 3. let's make our Hessian. So I got 6x, 6y, 3 and 3. This looks like quadratic form, right? Okay. And then I'm going to take the determinant of this, right? So this is the Hessian. So take determinant. And that's going to get me, what is that? 36xy minus 9. Okay. And then we have to determine what the values are there, right? So, so at 0, 0, this is equal to negative 9. And then at negative 1, comma negative 1, this is equal to 27, right? Okay, then how do we classify the Hessian? Let's see what it is. They got something nice for us? Yeah, here we go. Tensors, ew. What's going on here? AI mode, maybe? AI gonna tell me? That's a video. Okay. A saddle point is if the determinant is negative. Okay, so this is a saddle then, right? So this is a saddle. And then what about if it's positive? Oh, we have to talk about definite eigenvalues, dude. No, I don't want to get into this. Sorry, Femvox, how do you know there's a relative max, though? Here. Paul usually has it. These are my resources I use to, like, find stuff. The second derivative test. Oh, okay. This is what I want. I want this. There we go. Paul's great. There we go. This is what I want. See, do you see how, like, I was Googling that and I was getting nowhere? And then, bless Paul. Paul helped us out. Okay, so if D is greater than 0 and fxx is greater than 0, then there's a relative minimum. So let's look. fxx was 6x. So at negative 1, that's negative. So it's a relative maximum. You're right. Yep. Cool. So this one is then a relative max. Nice. Cool. And we're done. Good job, Odin.
Well done! Well done!
Thank you, Paul. Yeah, Paul helps us out for sure, dude. Long claps. Long claps. Okay, nice. All right. Let's see what else we got. Jose? Yes. Jose. Jose's next. Okay. We did this one. I'm very sure we did this one. Did we do this one? Volume of solid rotated by the region. 8 sine x, 8 cosine x, about y equals minus 1. Oh, I'm very sure we did this one. It may have gotten submitted twice. That's okay. Where did we do it, though? I know I did it. Yes, here it was. Yeah, we did it. This was it. Okay, Jose, if you're looking... This was the bunt cake we did. Yeah, it was kind of a mess. Okay, but we did this one. All right, so I'm gonna move that one off. Okay, so then the next one is Facintafo. Okay. Find the inverse of the matrix. Cool. So yeah, someone already suggested this earlier, but when you have these situations, you could use the adjoint if you wanted to. I'm gonna do this way because I think this is like, I don't know, it's easier for me to like make sense of it. You just set up the identity matrix over here, and then your goal is to turn this whole side into this side using row operations. Right? Nice thing about is that we have copy paste. Okay, so, and I always do like the snake method. So I go this way is what I do. So I try to like go in this order to make this thing look like this. So first thing I'm going to do, I'm going to add this one to this one. So I'm going to say like R1 plus R2 gets you R2, right? And let's see what that does. So 1 plus minus 1 will get me 0. 2 plus 0 will get me 2. 4 plus 3 will get me 7. 1 plus 0 will get me 1. 0 plus 1 is 1. 0 plus 0 is 0. Cool. Next step is to knock out this one. So I'm going to do negative. You advance level 2 on the education bot. There. That's dope.
That's dope.
Negative 3 times R1 plus R3 is going to now imply R3. Because I'm going to take this to like kill this off. So let's see what happens when we do that. So negative 3 times 1 plus negative 3, that's going to get me 0. That's negative 6 plus 1, which is negative 5. That's negative 12. Negative 2, that's negative 14. And then negative 3s of these plus that is negative 3. 0. And then that's also just 1. Cool. Okay. This is where things start to get ugly. Because, fuck. I gotta divide this all by negative 5? No, sorry. Sorry, no. I gotta... Oh, man. You like the use of color? Yeah, it's just easy to see, like, what the row operations are. Oh, I don't want to multiply one of these by 5/2, dude. It's gonna suck. I just don't want to. Fine. And I have to do this one. Is what I have to do, right? Yeah. I have no choice. I'm stuck. Fine. Okay. So, 5/2 R2 plus R3 implies R3. Femvox says just multiply green by 5 and blue by 2 and then add them together. Okay, let's do that. I think that's better than doing the 5/2 shit. I agree. Let's do it. All right, so 5/2 R2 goes to R2. No, sorry. 5 R2 goes to R2. 2 R3 goes to R3. Okay. So this is going to become 10, 35, 5. Do I ever teach linear relations? I can try. 0, 0. And then this is 0, but then this is times 2, so this is negative 10, negative 28, negative 6, 0, 2. Okay. So now we do R R2 plus R3 gets me R3, right? And let's see what we have. So this plus this will cancel this out. So this is going to go to 0. So 0, 0. That's going to go to 7. That's going to go to -1. That's going to go to 5. That's going to go to 2. Very cool. Okay, we're almost there. Now, here's my question, Fembox. Would you multiply this by -10? Would you do that? Or, sorry, -5. Okay, well, let's just do it. Okay, so, wait, sorry, yeah. R1. -1. Cauchy's residue theorem. Okay, let's do it. Sorry, so, negative... Oh, man. Yeah. And then we're just going to divide by -1 at the end of the day. Okay. -5 times R1 plus R2 gets me R2. This is the way. Yeah, okay, here we go. I'm getting it. So -5. So that becomes -10 plus 10, so that's 0. These are... Oh, wait, whoa. Wait. No. Other way. Yes. I fucked that up. Sorry. R1 plus -5. Sorry. No, wait. I had it right. I need this to go to R1. That's what I need. I actually hate this class. This is tedious, bro. Like, this is gonna be really tedious, honestly. It just sucks. Okay, sorry. -5 R1. I'm adding this to this, but then I'm making it this. I think is what's happening. Yeah? No. Yes. My head. Okay, so this becomes -5, right? This becomes 0. -20 plus 35 is 15. -5. Oh, plus 5 is 0. Oh, that's cool. -5 plus 5 times 0 is just still going to be... That's going to be 5, right? Yeah. And then this is still going to be 0. Okay, did we do that right? Yeah. -20 plus 35 is 15. -5 plus 5, 0. Yeah. 0 plus 5, 5. Yeah. Okay, cool. Good so far. Okay. Now, Jeff, what are we doing with these things, though? So, we came here. We're good here. I need to clear this one. You want to clear column 3 first? Oh, fuck. Yeah, the general, like, Gauss-Jordan pattern is to do this, usually, right? Because the issue here is that now I need this to clear this. -5 R3. Oh, I see. You would have had this clear this. Yeah, I agree with that. Okay. All right, let's roll it back. Roll it back. Yeah. Sometimes you want to go out of the order. Yeah, okay. So -5 R3 plus R2. Yeah, we're finding the inverse of a 3x3 matrix. And we're trying to do it without using fractions. This is the whole thing. This is the original one we're doing. Little puzzle. Okay. So, cool. So none of this changes, right? This is still 0, 10. And then this is negative 35 plus 35, so that's 0. And then that's 5 plus 5, that's 10. Negative 25 plus 5 is negative 20. Negative 10 plus 0 is just negative 10, right? Okay. This looks better. And then I think the next step we're going to do, right, is the thing we were doing with the R1s, right? So now I'm going to do... Oh, you want to clear this. Okay, and then we'll clear the other thing left next. I was thinking I could clear this, though, no? Shouldn't I just clear this? Oh, maybe because, like, 20 and 7 is kind of a bitch to deal with. Okay. Negative 7 R1. Wait, sorry. I don't like using minuses. Yeah. Well, let's do this. Okay, so negative 4 R3 plus 7 R1 equals R1. So, negative 4 of these plus that doesn't change anything. That doesn't change anything. Oh, wait, no, is equal to R1. Sorry, my bad. Sorry, this is going to turn into a 7. Galoy, vive la fin. Je m'appelle un homme dehors. Je suis. Okay, wait a minute. Negative 4R3 plus 7R1 is R1. Okay, so this is a 7 then? Right? And then this is a 14. Oh no, Femvox, dude, what? Negative 28 plus 28 is 0. Okay, that's 0 at least. Plus. Okay, negative 4. So that's 4 plus 7. That's 11. Android or iPhone? I'm an Android guy. Pixel for life, dude. Negative 20 plus 0 is negative 20. Negative 8 plus 0 is negative 8. Okay. Last one. And then we got to divide everything. Yeah, but this is a mess, right? To get rid of this. And finally, for the coup de grace. Yeah, finally here, we're going to do negative 7 R2 plus 5 R1 gets you R1. I really like this. This is cool. We're doing this without ever dealing with fractions. And the way we're doing that, is that we're doing a bunch of like systems of equations by elimination stuff, basically. Okay. Negative 7 plus 5 R1 is R1. So this is going to be 35 now. Right? That's negative 70 plus 70. That's going to be 0. Love that. Negative 7 plus 5. That's still 0. This is all busy work. I agree. Negative 70 plus 55 is negative 15. Wait. Yeah. Negative 15. Right. And then this is 140. 140 minus 100. So that's 40. And then this is 70 minus 40, which is 30. Okay. Final step is to divide. Right? So R1 over 35 gives you R1. You want my specs? You can type in my Discord, or sorry, in my Twitch. If you just type specs, it'll come up. Yeah, that's my specs. And then R2 over 10 implies R2. And then R3 divided by 7 implies R3. That's the last step. So, what do you get? You get a whole mess. Alright. Well, the nice thing is, this is going to turn into 1, 0, 0, 0, 1, 0, 0, 0, 1. But then these are all over 7. The other ones are all over 10. Oh, so that's actually kind of nice, because divide by 10, we just get rid of the zeros. Beautiful. I will definitely fuck this one up. And then R1's over 35. Okay, so that's negative 15 over 35. So what's that? 3/7? And then this is going to be, divided by 35 is going to be 8/7. And then this is going to be 6/7. Cool. Is that correct? Let's see if, like, all the work we did. 6/7? Oh, no. Oh, my God. You guys with the 6/7. All right. Let's just see if, you know... Actually, you know what? Actually, I can do this on my calculator. We'll do this on my calculator real quick for you guys. So yeah, if we go to wait, second quit. Second matrix, edit. Let's make it a 3x3. And then we have 1, 2, 4, -1, 0, 3, 3, 1, -2. Quit. Second matrix, math. Is there an invert button? Oh, there isn't. Okay, well, whatever. You can just do this. I think you can literally just do the matrix of the -1. It'll do it. Yeah. Wow. Now, here's the cool thing. Do you think I can convert this to a fraction? I do like that they got 1 minus 2, 1. 1 minus 2 minus 1. Right? But here's my question. I wonder if I can take this. Will it do it? You think so? Oh, fuck yeah, it did do it. Oh, that's so dope. Wow, I got it right, dude. Look at that. Yeah, dude. Hell yeah. That's great. Wow, we did it. Yeah, look at that. Look at that. That's fucking sexy. I'm pretty handy in the TI-84 after 20 years. By hand is insane. I agree. But I'm a pretty insane person sometimes. So anyways, yeah. I mean, this is how long it takes to do by hand, right? Fuck your teacher if they make you do that on a test. That's just terrible. No. Yeah, I struggled following an Octvid. Wait, like an 8x8? I ain't doing that shit. Ain't doing that. Okay, nice. So that was Festinfo. Oh, let me refresh this. Oh, organic. Oh, he's the Albanian sorry, organic chemistry tutor. Yeah, he's a cool guy. You know, he taught at my university. He taught at UCLA. Thanks for the follow, Neptunic. All right. We got a bag of cement question coming up next. Again, if you're watching the stream here and you have a question, please feel free to add it to the queue here. If you ever want to see like what's on the queue, you can go to here and then just go to live queue, and then you can click on any of these usernames. So I'm waiting for Jamie to come back. This was Jamie's question. Jake. Oh, I need to. We refuse to do that one. Oh, you submitted the same question twice. Oh, so actually, let me just clear that from the queue. I don't know why it went in twice. Okay. Okay, cool. There we go. So, yeah, Acid, Yetavir. Great. Oh, and I do see this other one from like, yeah, okay, cool. How do you send questions? So there's a website down there, actualdiscord.com/submit. Okay, so Dead Girl Talking says, my general issue with this problem is understanding what is happening because I tend to mess up on my setup, which can mess everything else. I agree. Physics is all about the setup. Physics is like really important. So, sorry, the setup is very important. I'm losing my brain. Okay, here we go. 35 newtons attached from 3 ropes as shown below. The 2 ropes attached. Theta 160, theta 2 is 40. I know what fucks you up. It's the sines and cosines here for sure. Find the tensions. I'm a physics teacher, physics professor. There you go. Whatever you want to call it. Yeah. So what I like to do here is always, when I have these questions, Dead Girl Talking, I think about where the center of all these ropes are connecting, and I draw force diagrams based on that, okay? So let's consider this area here. Let's let this point, and let's think about what all the forces are, okay? So let's draw this. So I know I have plasma physics. That's what I did my PhD in. I don't do research anymore though. I just teach. And then this is T2. And then this is T1. Okay? Now, we know that the bag of cement weighs 325 newtons. So, looking at the cement, if that has a force of gravity equal to 325 newtons, then that means in order for it to stay upright in equilibrium, we need T3 on the bag to also equal 325 newtons. And the rule about like forces and tensions and ropes is the tension is the same on either end of the rope, it's just in opposite directions. So for the bag, it has T3 pulling up 325, but on the joint here, that means there is 325 newtons pulling down. Okay? So if I draw a force diagram for the bag, 325 is pulling down, but 325 from T3 points up. So then looking at the joint here, or the junction, that T3 needs to be 325 pointing down. Okay? Is that good so far, Dead Girl Talking? That is because of the weight, 100%. Sometimes they wouldn't give it to you in newtons. They would give this into, like, kilograms, and then you would need to do that as equal to mg. Okay? They gave you the weight in newtons, so that tells you what the force of gravity already is. Okay? So the next thing I need to do is break up my forces into components. And so, I'm going to use different colors here, just to make things nice. So let's call that one T1. Let's call this one T2. Okay, so T1 is going to have a couple components. It's going to have a Y component and an X component, okay? So I'm going to call this like T1X. I'm going to call this T1Y, right? And then the same thing for the red one. The red one is going to have... Oh, so let's move this on the other side, sorry. Put that over here. This is going to have a T2Y and a T2X. Right? That points that way. Law of cosines makes this lunch money? Yeah. Okay. Good so far? So, the next thing to do is the sum of the forces in the x direction and the sum of the forces in the y direction. So, in the x direction, I have negative T1x, because, right, that's pointing to the left. I have positive T2x, that's pointing to the right. And there's no other forces in the x direction. And that all has to equal the mass times acceleration, but the acceleration is 0, right? Because this thing is not moving. So we know this is all equal to 0. In the y direction, I have both T1 T1y and T2y pointing up, so those are going to be positive. And then I have minus T3, which is the 325, pulling down. And that all equals a 0. Cool? Okay. Next thing I want to do is I want to write out what these are in terms of trig functions. So this right here is theta 2. Okay? So if I were to, and this is a right triangle, right? The y and the x-axis make a 90-degree angle. So if I were to look, for instance, at the sine of theta 2, we know that's the opposite over the hypotenuse. So that would be equal to T2y over T2. And so I can then move this over here, and I get that T2y is equal to T2 sine theta 2. Does that make sense how I did that? And then by the same token, T2x will equal to T2 cosine theta 2. Great. Okay, cool. And then it's the same thing for T1. So that holds there. This holds here. Okay, so 1, 1, 1, 1, 1, 1. All right, let's go substitute that stuff in over here. Okay. So here, I'm gonna move this over. I think I want to move this over. I think I do. If I move this over, that means that T2. Oh, actually, I know how this works. Yeah. The hardest math, probably complex analysis. Okay, so that's that. And then we had for here, I had T1 sine theta 1 plus T2 sine theta 2 equal to 325. No. So why? Not a stupid question. Why is it not involved in X and Y? Because the force of gravity on T3, which is on the cement, that only points in the up-down direction. So I only need to, so that does not get included in any of the X component forces. Not a dumb question. It's a good one. It's a good one. Ugh. All right. Is learning Calc 2 as a 9th grader tough? Yeah, that's pretty intense. Let me remember how we do this. There's a trick for this. I mean, at the end of the day, I have all the numbers for everything, right? I have all the angles. They gave me theta 1 and theta 2. I just wanted to see if there was a nicer algebraic way to do it. What's up, Muslim Coder? Yeah, I can't. Yeah. Okay, cool. Whatever. T2 is equal to T1 cosine theta 1 over cosine theta 2. So then I'm going to plug that in for her. So we get T1 sine theta 1 plus T1 cosine theta 1 sine theta 2 all over cosine theta 2 is equal to 325. Whenever, Muslim, if you want to learn some math, just submit a math question. There are plenty of people asking math questions. So I can pull a T1 out of both of these, right? So this is T1 sine theta 1 plus, and here, let's make this like kind of pretty. I want to make this kind of pretty. I'm going to multiply this by cosine theta 2 over cosine theta 2 so that I can combine the fractions. So that's sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2 all over cosine theta 2 is equal to 325. Okay. And then let's remind us what the angles are. Theta 1 is 60, theta 2 is 40. Samsung says, any more tips to keep going in math? Because there's, the more I learn, the more I realize I know nothing. No, bro, that's very common, dude. Yeah, that is super common in any field. The more you know, the more you realize you don't know. Don't let that discourage you. That's just a sign that it's working. You're learning. If you're talking about like motivation, I think having some sort of goal that you're trying to like use the math for can kind of help. And if you don't have like something directly applied, maybe having like a reading group that you're a part of, or like practice question test things, or just some sort of community. We have a really big community here, Samsung, on Discord. You're more than welcome to join. And I can point you to some other really awesome math streamers, and they have their own Discord communities, and they're just super hyped with just learning more math. Oh, good. Oh, there you go. Electrical engineering is your final goal. Oh, yeah. So then just keep doing double E problems until you can't do them anymore. And then that'll teach you the math you need to use. Yeah, it does look like an angle sum identity. Can we be friends? Yeah. I mean, are we not friends right now? I'm friends with a lot of people on the internet. Just be nice to me. Okay. So, yeah, is that a product of sum? This is physics. Okay, first of all, make sure in degree mode, right? Good. Okay. So, sine 60, cosine 40. Dude, I'm pretty sure that's a sum to... Yeah, isn't it? Fembox, it is, right? Cosine 60. Sine 40. Do all that. Divide by the cosine of 40. Bingo bango. And then do 325 divided by that. So you get T1 is equal to 252.8. Here, T1 is equal to 252.8. And then you take that and you just plug it into here to get T2. So I'm going to do that times cosine of 60 divided by the cosine of 40. And that's going to get me 165 on the dot. So then T2 is equal to 165 newtons. Cool. And I think that's it. Yeah. And then, yeah, T3 is already equal to 325. Cool. Did that make sense? Dead girl walking? We agree. Fembox says we agree. I get it now. Thank you. General question. My professor likes to do things in vector component form. W is equal to 0 minus mg. Would he take off points if I did it this way? No. I think as long as you're separating things out into x and y, you're okay. Yeah. No. This is totally okay. W equals 0 minus mg. Yeah. I think you mean 0 comma negative mg, right? Yeah. You still have to do things kind of in components. Yeah. This is the only way to do it. Anyways. Nice. Good question. I have an exam in 2 weeks. Any general tips for setting this up? So, especially in mechanics, in physics, there's only so many questions that can get asked. And I know this because, like, I've written exams. What really helps is seeing these situations, like, over and over again. The other one I always see is... It's like the block attached to a wall, and there's like one rope. I mean, this is a very common one. This one does come up a lot. In general, I like to, especially if you have multiple ropes, define a common point they're all connected to, and then draw out the force diagram for that common connected point, and then break everything into components, and then add all the components, and make sure like the components add to 0 if it's in equilibrium. That's just a general strat for any of these equilibrium problems, is draw a force diagram, get all the components, set equal to 0. Yes, the incline problem is definitely on it. Yeah. Well, someone asked about that one actually earlier. I can go back and do it in a bit. Jamie, was that you? That wasn't you, Jamie, right? Wait, your name is not Jamie. Your name is Dead Girl Walking. Unless, wait, where was Jamie's question? Sorry. Was it this one? Oh, this one. Can you teach trigonometry from scratch? That would take a lot of time. Yeah. So yeah, this one comes up a lot as well. Ooh, good. Yeah, where can I find the work? Oh, let me look at Femvox's method in a second here. Femvox says there's a faster way to do it. But this is the standard way your teacher wants you to do. If you start doing law of cosines, the teacher's going to start thinking you're using ChatGPT or something. So, Dead Girl, I can post this in our Discord. If you want to join our Discord, there's a link here. There you go. And then just tell me what your username is, and I'll tag you for the channel it's in. It's in the stage channel. That's where I do things on Discord. But just let me know. Or DM me. I'm Dr. Gold on my Discord. Nice. We got 25 follows this stream on TikTok. That's pretty dope. I think we have 1, 2, 3, 4, 5, 6, 7, 8 on Twitch today. God knows. On YouTube, we get like 60 or 70. It's awesome. Username is Dead. Okay, great. Okay. That'll be easy to know. There you go, Dead. I tagged you, so you should be able to see it. Also, yeah, you get a point for asking a question. We give out gift cards and stuff if people ask enough questions in our Discord. And do other stuff, like if you get good grades on your classes and you post screenshots, if you get at least 7,000 steps a week, 7,000 steps a day for 4 days a week, you get points for that. It's a whole like fun little gamified Discord. We're an official nonprofit, so none of it is a scam. It's all real. It's just generosity. So, but yeah, the knowledge is free too. So enjoy that. Hell yeah. Okay. That was Dead Girl. Okay, so let me see. A siege. Okay. This question next. If you ever want to see where the queue's at, here, let me just mark these. You can always go to the website that is linked down below. Click here on live queue, and then you can see the questions that have been submitted, and then you can always click. Sorry, let me show us here on Twitch. So if you go to the website, you can also find all our stuff. You want to watch on Twitch instead of YouTube. If you want to YouTube instead of Twitch, you want to join our Discord. If you click on live queue here, here's the queue of the questions that have been submitted, and you can always click on the username to see what the question is. And this is also a good way for you to make sure that your thing got submitted. So Habaka, I do see this. This is cool. This is stats. Or no, it looks like physics. This is cool. I don't even know what this is, but this looks cool as well. And then Yadavir, what'd you get me? More series. Okay, cool. All right, but let's do this one. This one comes from Asij or Osage. And so Osage is asking me, two triangles are said to be similar if their corresponding angles are congruent and the corresponding sides are proportional. Cool. Yes, these are, yeah, similar triangles, I guess, right? Two parallel walls, AB and CD, where the northern ends are AC and are A and C. Okay, sir, let's do this. Sorry, let me draw this. So A and B. And then we have C and D are joined by a fence from B to C. Okay, so then there's a fence from B to C like this. Okay. The wall AB is 20 meters long. Okay, so this is 20. Angle ABC is 30 degrees. Love that. Well, let's use different colors for angles. And the fence BC is 10 meters long. Oh, this is a classic similar triangles question. We're going to do something like this, I bet, aren't we? A new fence is being built from A to a point P somewhere along CD. Thanks for coming around, Jeff. Yeah. Night night. Hope to catch you again. Yeah, we'll be on tomorrow. We're streaming tomorrow. What's today? Tuesday? Yeah, I'm streaming tomorrow and Thursday. So. The new fence AP will cross the original fence BC. Wait, AP. Oh, okay, okay. So then this is happening. Okay, so this is going to be O. Wait, but 10 is the whole distance, right? It's so easy to mess up. Messing up, you shouldn't be, don't be afraid of messing up. Messing up's how you get better at shit. It is easy to mess up, but that makes learning even easier the more you mess up. Okay, and then this is some point P. Let OB be meters X. Okay, OB is X. Okay, where's OB, dude? This is X. Determine the value of X that minimizes the total area enclosed by OBA and OCP. Wow. Oh, man. How the fuck do we do this question? I see what's happening. It's kind of cool. So, we're saying a derivative and a partial derivative. Just whether you like care about all the variables down the road. So, we're saying I can move this, right? And I want to find what minimizes the area, the total area of this and this, given that X can't be bigger than 10. If you want to send the solution, I mean, I like to attempt this. So, I mean, the cool thing I know is that if this is 30 degrees, since these are parallel lines, this is what we call a transversal, right? Two parallel lines and a transversal. This is also 30 degrees, right? And then if I want to talk about the area... Oh, yeah, no, yes, I think I got this. Okay, so the area of triangle OBA is going to be equal to the base. So 1/2 times the base is 20, times whatever the height is. Now, the height's actually kind of tricky. So the height is going to be this, right? This will be the height. And that's related to X and the angle here, right? Because this makes a 90-degree angle. So, was it sine of 30 degrees is equal to H over X? Opposite over hypotenuse, right? So H is equal to X sine 30. Cool. So we can say X sine of 30 degrees. What guitar solo should I learn? Crazy Train? That's a good one. Okay. And then the area of OCP is again going to equal 1/2. Now this is interesting. The base is going to be CP here. Oh, very cool though. Okay, but this is very cool. This is such a cool question actually. I like this one. This triangle right here is similar to this triangle right here, which means the ratios of the sides are similar, okay? So, if we were to, for instance, call this distance here y, because I need to figure out a new height, right? I'm going to need to figure out, like, this height. Call this, like, h2, right? h2 is equal to y sine of 30 degrees. Okay, but here's the cool thing. The ratio of this to this is the same thing as the ratio of this to this. Because this side... Yeah, I think that's right? Yeah, there is a queue. There's four questions in the queue. And then the website's down there. actualdiscord.com/submit. And there you can click on the queue and see like what's happening so far. This is super cool, man. I fucking love it. This is a really cool question. So this is equal to CP times the height which is y sine of 30 degrees. But I think I'm right about this, right? Because this is 30, this is 30. Which means this angle equals this angle, which means this angle equals this angle, right? So now we have similar triangles because all the angles are the same. If you have two triangles with all the same angles, then the proportions of the sides are the same too. Oh, this is so cool. So what does that tell me? That tells me that x over 20, right? So this over this is equal to y over CP. Or that CP is equal to 20y over x. Yeah? Ooh, it's a quadratic then, no? Okay, so we can rewrite this as 20y over x. Okay, cool. Determine the value of x that minimizes it. Okay, so the area, so area total is equal to 1/2 sine 30 degrees times 20. So it's really 10. So 10 sine 30 degrees. And that's going to be x plus y squared over x. Right? Yeah. Okay. Bum, 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 bum. Oh, wait, and I think we want... Oh, man, but that gets me 20 over CP. Oh, find the div x. But now I've introduced another variable. That's the issue. Let's see if we can use this to do something, though. So what is that? Y is equal to CPX over 20. So y squared over x is this squared over x. So what is this whole thing? That's... How are vectors used in Calc 3? Oh, they're used all the time, dude. CP squared x over 400. Right? After Dark with Dr. Gold. Damn. I guess x has restrictions on it, though, right? Because if I were to take the derivative, so dA... dx... Well, no, it's dA... It's dA... dA dCP, right? Because I want to figure out... No, I want to figure out the value of x. Sorry, so dA dx. Which would equal to 1 plus dCP squared dx times 1 over 400. So then this is the question. How does CP change with x? Right? Oh shit, no, sorry. This is a product rule. Fuck. No. Alright, let me see the solution he sent. And I'll check it. I think I'm close. Have I played Red Dead Redemption 2? I have not. Oh, also, Fem, sorry, I meant to see your Law of Signs thing. What'd you do for Law of Signs? Where was it? Where'd you send it? Oh, you sent it in office hours, I think. Oh, this is the law of sine solution for, what was it? This question here. Oh, I see it. I don't think I'm going to go over Cauchy's residue theorem tonight. No, I don't think so. Oh, I do have to go in like 5 minutes. Fuck. Oh, I have another student I have to teach. Okay. Okay. Wait, where's the 325 come from? Wait, 60? What? 100? 30? 50? Oh, I see. You're building a triangle. Oh. Oh. It's a 3... You love doing this, Femvox. You love... Yeah, this is so unique. I don't think I've ever really seen this done. This is true, though. You're just saying that all of this has to be equal to 0. And then, yes, bingo. It's angle, 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 side. And you have 2 angles. Oh, man, that's so cool. That's really cool, Femvox. I like that. That's really fun. Yeah, exactly. All right, let's see what's happening here. So, I agreed with doing the sine 30 thing here. And then... Oh, they get a little bit more complicated. Yeah. And then... Wait, whoa. Area is equal to 10 minus x, 20 minus 20. Okay. But then what's happening here? Are they taking the derivative? And setting it equal to 0? I think I was kind of close with this. Oh, interesting. If this is x, this has to be 10 minus x, I guess. Yeah, okay. Yeah, 20 to PC is the same thing as x to 10. Wait. Do we know that's 10? Sorry. Where did we know that? Oh, okay. Because OB can be at its least 0. Wait, how do we know that's 10, though? Oh, I get... No. If I know this is 20, I know this is 10. I get it. You're doing 20 sine 30 plus 10 sine 30. Yeah. Okay. Anyways, this is cool. I like the solution. That's fun. Okay. I have like 10-15 minutes. Let me just see if I can speed run through the rest of the questions that got like submitted here real quick. I'm just gonna pick questions I think I can do really quickly. You're amazed watching this? Thanks, Harrison. This one doesn't look too bad. Let me see if I can just speed run it through it. You know what I should do? I should create like a little mode on a little whatever, like a button where it's like, now it's time to just speed run. Just see how much can I do before I have to actually go teach another student. Okay, 2 functions. A section of them is shown. Determine the values of A, B, and C. Oh, okay. So this is 1, 2. So, what is this? F of 2 is equal to G of 2. Squeeze theorem is great. I love the squeeze theorem. So that's what that tells me. F of 2 equals G of 2. I also know that G of 0 is equal to 5. Right? And I know that F of 0 is equal to 1. I think those are some cool things, right? So let's try to see if that helps us. So G of 0, that tells me negative log base 3 of C plus 5 is equal to 5. Cool. So based on that, I know that C must be equal to 1. Right? Because log of 1 is 0, and then that would get me 5 equals 5. Cool. F of 0 is equal to 1. Okay, so that's 3 log base 2 of A plus B is equal to 1. That doesn't really help me too much, does it? Unfortunate. Well, we got C. Okay, but then I know that... Okay, so this is true. But then I also know that f of 2 equals g of 2. So 3 log base 2 of a plus 2 plus b must be equal to negative log of 3 c plus 2 plus 5. Oh, and I know c is equal to 1, right? So this is log base 3 of 3. Log base 3 of 3 is just 1. Okay, so this is the other thing. We know this is true. So, okay. So 3 log base 2 of a plus 2 plus b has to be equal to 4. Odin, I did your question, Odin. Remind me your name in Discord. What's your name in Discord again? We did your question, the saddle one. We did all this. I posted it in the office hours. Funny Snake. Okay, cool. Nice. Well, here, I'll tag you. Funny Snake. And then I'll give you a coin. Yeah, good question, Funny Snake. There you go. Okay, does this help me out, though? So I know this is true. And I also know that 3 log base 2 of a plus b is equal to 1. Oh, okay. We can subtract these two, right? Because this cancels. Cool. So this is just equal to 3. So this is 3, and then this is log base 2 of this minus this. You can combine logs. So that's a plus 2 over a is equal to 3. Log base 2 of a plus 2 over a is equal to 1. So that means a plus 2 over a must be equal to 2. A plus 2 equals 2a. A equals 2. No. Yes. A equals 2. Cool. And if a equals 2, this goes away, so then b equals minus 2. So b equals minus 2, a equals 2, and you're done. Good question.
Well done! Well done!
Thought that was kind of cool. Yadavir, I don't know if I can do yours in the next 5-10 minutes, just because it looks like a really big series. I like you submitting these, though, dude. Maybe if you submit them a little bit earlier in the stream, I can do them. And again, where do you see my solutions? If you come to our Discord, I'll post them in the Discord. You're right. I should work on and I think I will. I'm gonna work on beefing up the website to also like include the solutions. That's a good idea. Oh, I like that. Let me fix that. All right, or not fix that. Just add that to the suggestion box. Yeah, let's see. Like, put a way to upload solutions to problems. That's a really cool idea. I like that. Ollie the Lolly. Ollie, which one was your question, Ollie? Which one did you ask, Ollie? Was it the question we just did? Was this yours, Ollie the Lolly? I see you in my stage. I see you in my Discord stage. But I also here I can like just let me just post this one in. This one was 340. So here at Ollie, so far I've just been posting them in the Discord stage chat. But I like the idea of, for instance, this website. Oh, Able C Joko. Oh, you were Osage, right? Okay, cool. So on here, when I have like live queue, I think it would be cool to also be able to like have something that says question done and then have a link to the solution as well. That's a really cool idea. Yeah, sorry, Osage, did I post your solution? Oh, you sent the solution for it. Oh, yeah. That was me trying to do this. This is a cool question, Ollie the Lolly. Yeah. Okay, all good. But yes, I like this Yadavir. I just don't know if I can do it really quickly. B and AP and A1 equals that. A102 equals 405. So this is an alternating series, which is equal to a multiplicative series, where PI are prime numbers and B is contained in the natural numbers. Oh dear. Yeah, I don't know if I can do this in 5 minutes. I love it though. Nice question. It's fun. Let me see Habaka real quick. I appreciate the hard questions. I will also probably... Hi, I'm the John submission. I see yours as well. Yep. I could do this also really quickly too. Yours is not too bad. This looks insane. Yeah, that other stuff's insane. You're not gonna have to do that. Let me see. So, this is like the grading book for this. Okay, who cares about grading? Okay, circular coil of insulating wire has a radius of that and contains n equals 90 terms. A uniform magnetic field points parallel to the central axis. Next, the coil is bent over the course of 75 seconds so that each turn of the coil changes from a circle to an equilateral triangle. Wait, whoa, what? No. Dude, no, what? Oh my god. Whose perimeter equals the total circumference, the total length of the wiring and number of loops remains the same as it's being bent. What is the induced EMF? Okay, well, I can try to do this. So, EMF, whatever. Oh, we ran out of music. 1 second. Let me fix the music. We need the music. I can't work in silence. I grew up in a big family. There we go. Okay. So EMF is equal to negative delta phi delta t, which is equal to delta BA over delta t. And so what's changing is the area, right? Yeah. So the area is going from a circular coil with a radius of 5 centimeters. Okay, so let's see. So the area of a circle is pi times 0.05 squared. And then the area of the triangle. So there's an easy way for this. Let me just area of equilateral triangle. There's an equation for it. Bingo. This is what I wanted. Whatever. I'm just stealing this. It's just easier. Okay, the area of an equilateral triangle is equal to the square root of 3 over 4 times the side length, the side squared. Okay? And in this case, we know A is equal to the circumference of the original circle, which was 2 pi times 0.05. And then that's all divided by 3, because it gets divided into 3 parts. Okay? So the area of the triangle is going to be equal to the square root of 3 over 4 times 4 pi squared 0.05 squared all over 9. So this cancels. So what is that? Sure. Square root of 3 pi squared over 9 0.05 squared. Okay, so the change in the area, so delta A is going to equal to 0.05 squared times 0.05 squared pi, and then it's going to be 1 minus the square root of 3 pi over 9. Okay, that's a change in the area. And then you need to divide, and then you need to multiply that by the magnetic field, which was 0.95 Tesla, right? And then you need to divide that by delta T, which is equal to 75 seconds. And then I think you need to multiply by N. Yeah, 90 turns, right? And then whatever, multiply by 90 terms. Yeah, 90 terms. Cool? That's what the answer is eventually. I'll leave it as an exercise to the reader to do the actual calculator stuff. But that's also a cool one. Yeah, Habaka, you're right. Yeah, you're more than welcome. Habaka, are you in my Discord so I can like send you this solution? Bro's been mathing for 3.5 hours. Thanks, bro. Yeah. No, not yet. Okay, so if you want to, that link down there where you submitted the question, there's also a link to the Discord, and then I post the solutions here on there. Also, this is all on YouTube as well, so if you want to rewatch this at any point in time, TikTok doesn't record my lives, but Twitch and YouTube do. So just follow us on Twitch or YouTube, and then go back and watch the recording. All right. Last one. This is for you, John. Klufel. Consider the function cosine 2x plus cosine squared of 2x for... Okay, show that f prime of x is equal to that. Cool. Easy. So f prime of x is going to equal the derivative of this. So this is a chain rule, right? So the derivative of cosine is negative sine of 2x times the derivative of what's inside. That's times 2. And then this is plus 2 times cosine to the 1 of x. So just cosine of x. So here, this is another kind of interesting chain rule. Cosine squared of x is the same thing as cosine of x squared, which the derivative is to like pull this down, drop the power by 1, and then to take the derivative of what's inside. So that's cosine of x, and then this is minus sine of x. Which, okay. I think I did that right? Yeah. Right, derivative of cosine negative sine 2x. How do I show this as negative 3 sine of 2x? I don't see that. Oh. Wait, sorry. Oh, this right here. 2 cosine x sine x, I believe is equal to sine of 3x. Or is sine of 2x, right? I think is that an identity that's true? I believe it is. It has to be. So, minus 2 sine 2x minus, thanks Jack, yeah, okay, cool, minus sine of 2x. So you have 2 sine 2x's, another sine 2x, that's gonna be minus 3 sine 2x. Okay, cool, love that, that's good, sweet. Find the coordinates of any relative extrema. Okay, so I need to know when this is 0. So I ask myself, when is sine of 2x equal to 0? Okay, well, sine of u, for instance, is equal to 0 at 0 plus n pi, basically. So 2x is going to be 0 at n pi over 2. So sine of 2x is equal to 0 at n over 2 pi. So that's going to be at x is equal to pi over 2 pi 3 pi over 2. And where are we allowed to go up to? Up to pi. Okay, cool. And then, oh, wait, so I can't even go up to pi over 2. Oh, okay. So there's only extrema at 0 and pi over 2. Yeah, there you go. So these are the critical points. Clue? Does that make sense? Critical points are where the derivative is equal to 0. Okay. No. You tell me if it doesn't make sense. I'll go over it. It's okay. Okay to me is always like kind of suspicious. It's like, does it actually make sense? It's like, yeah, I remember, yeah, it's, if you're ever like dating someone and they say like, how are you doing? And they say, I'm okay. It's like, no, something's wrong. No. Critical points are where the first derivative is equal to 0. Jack, right? And, we use the second derivative to determine whether they're maxes or mins. So the derivative is 0 at these points. Yeah, good. Yeah, so these are the x coordinates, and then I need the associated y coordinates with that. So I have to take this and plug it back into what my original function was to get the y coordinate. Sorry, this was the original function, right? So sorry, yeah, this is not a point. Sorry, these are the x coordinates of the... You're right, I should have gotten the y's as well. So if you plug 0 into here, okay, that's going to get you cosine of 0, which is 1, plus cosine of 0, which is 1. So that corresponds to a y coordinate of 2. And then for pi over 2, that's cosine of pi. So that's -1. So you get -1 plus 0. So then this is just -1. Is it -1 though? Sorry. Cosine of pi is -1. Cosine squared. Yeah, no, it should be this. It should be 0, 2. Pi over 2, comma, -1. Oh, yes, and sorry, pi works as well. Sorry, we're allowed to also include pi. So pi is also a critical point. And that ends up being cosine of 2 pi, which is 1, plus 1, which is 2. Okay, so then you have pi, comma 2. Yes. So these are the official critical points. And the way I did that, right, is I got this for my derivative. Right? I said derivative is equal to this. And then I said, okay, let me set f prime of x equal to 0. So that means this thing, -3 sine of 2x, has to be equal to 0. I don't really care about the 3, right? I can get rid of that. And so that just tells me that sine of 2x has to be equal to 0. Right? So here. Sine of 2x must be equal to 0. And this is where it helps to have your unit circle kind of memorized. Because for sine, sine is going to be 0 here. So here, when, so here, sine of 0 equals 0. And also here, sine of pi is also equal to 0, okay? And then it repeats, right? Sine of 2 pi is also equal to 0. But, and that's why I wrote this. I said sine of just a regular variable is 0 whenever that regular variable is equal to 0 or like multiples of pi. But what I was given was sine of 2x. So in order for this whole inside thing to be equal to 0, x would need to be 0. In order for this whole inside thing here to be pi, x could just be pi over 2. Because like 2 times pi over 2 just gets you pi. And then remember, sine of pi is 0. And then if x was equal to pi, then you get sine of 2 pi. Sine of 2 pi is here as well. This is sine of 2 pi. And that's also equal to 0. And then you can't go any further, right? Because x can only go up to pi. So these are your 3 x coordinates for your critical points. To get the y coordinates, you then need to take these x values and plug them back into what the original function was. Because the original function takes x values and spits out y values. So that's how you get these. Okay. Find any points of inflection. So in points of inflection... Yeah, no, it's okay, Sisville. Yeah, tell me if it doesn't make sense. Inflection is where f double prime of x is equal to 0. So this was f prime of x. So then f double prime of x again, is just going to be equal to -3 times the derivative of sine of 2x. The derivative of sine is cosine. So I can say, cool, cosine of 2x. But you have to make sure. I have to also multiply by the derivative of what's inside. So that's times 2. This is the chain rule. So now I get -6 cosine of 2x. Okay. For cosine, that thing is 0 whenever the angle is either pi over 2 or 3 pi over 2. Both of these angles will get you cosine is equal to 0. So looking at this, right, I'm like, all right, cool. So x could be equal to, it could be equal to like 1/4, like pi over 4, right? Right? Because if I plug pi over 4 into there, 2 times pi over 4 gets me pi over 2. So it could equal pi over 4. It could equal also 3 pi over 4. And that's it. Because you can't go higher than that, right? Because we can't go higher than pi. Yeah. So 3 pi over 4 times this would get me 6 pi over 4, which would get me 3 pi over 2. And cosine of 3 pi over 2 is also 0. Okay, so then these are the points. You need to plug them back into here. So, plugging it back in. If you plug this in, you get cosine of pi over 2, which is 0. Plus cosine squared of pi over 4. So, cosine of pi over 4 is equal to square root of 2 over 2. So, cosine squared is going to equal to square root of 2 over 2 squared. So, that's 2 over 4. It's 1/2. So, this right here corresponds to a y equaling 1/2. This is also 0. And then cosine squared of 3 pi over 4. I think it's the same thing. It's also 1/2. Yeah, because it's going to make it positive. Okay. So now your inflection points are pi over 4, comma 1/2. And 3 pi over 4, 1/2. Yeah? Does that look good so far? Okay. And then sketch the graph. Just sketch it. Cool. Great. Okay, awesome. I'm going to save this for you, Clue. If you want to join our Discord, it's in the office hours channel. But you can also feel free to just send me a DM, and I'll make sure you know where it is. Okay, that's it. I gotta go run. Thank you, everyone, for coming to Actual Education Office Hours. Really appreciate all the questions. We will be back tomorrow. That's going to be at 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Feel free, come on by. If you ever want to figure out what our schedule is, the website link down below. You can click on the streaming schedule here, and that'll tell you where you can find us next. So we'll be on tomorrow later. Zach has an awesome stream at 11 a.m., so make sure to go on by. Say hi to him if you have more advanced math questions. We can help you out. If you're watching us on Discord, or sorry, if you're watching us on Twitch, I'm going to go raid somebody real quick. Raiding is just a way that we like support other streamers that are online. So looks like who's on? A lot of people on. 4 hours is abysmal. Oh wow, we almost did hit 4. Wow, holy fuck. That's pretty high. Okay. I like Nerduino. Go say hi to Nerduino. He's great. Cool. Alright, awesome. Enjoy your Tuesday. We will see you tomorrow. Peace.